Hi my dear NEET warriors, welcome to the chapter number 1 of your Physics 11th Standard NCERT, which is Units, Dimensions, Errors. And in this session, I'm not only going to cover the NCERT lines and all the important NCERT questions from not just the board perspective but also the NEET perspective. And then we are also going to see the PYQs of Units, Dimensions, and Errors which were asked in the previous papers like be it NEET, AIPMT or such medical entrance examinations. So this is a proper marathon one-shot lecture where we start from the basics and we level it up slowly from NCERT level to the PYQ level. You don't need to watch any other video after this. Nice to see all of you back on the channel, and this is your Captain Shreyas. Good evening. I hope you have smashed the like button and I hope you have also hit the subscribe button. Welcome aboard Avi, Nitin, Aditya, hello, NEET Tamil Nadu, hello, good evening, and Baswaraj sir too is here lighting up the chat box. So I hope you guys are all ready to light up the chat box and not just attend the session for the sake of it, but also secure your 4 marks to 8 marks in the NEET 24 and 2025 examination. Minimum 1 question, maximum 2 questions will come. So just this lecture is more than enough, right? So let's get started. Good evening, my dear warriors. Nice to see all of you back over here. Yes, good evening, good evening. So let's begin with the lecture. Let's start. And before we start, one small information which everybody must be aware of. And see, what happens is many people join random Telegram groups and it is not very useful, and often it is just some random things which are going on. But on our Telegram channel, if you are already a part of it, there is a lot of educational content that goes to all of you, and one such thing is the quizzes. So we share quizzes, PCB, and there is a quiz bot which takes in your answers and replies to you and also gives you the solution and the answer key. So make sure you are participating in the NEET quizzes in the Telegram channel. So if you are not yet a part of the Telegram channel, make sure you are a part of it by clicking on the link which is there in the description box below. So make sure you give all these quizzes, okay? It's fun. It's like you are talking to someone and somebody is like, yes, no, okay, do this, do that. So it's fun. So get a lot of educational content from our Telegram channel. So let's begin. Thank you, Lakshmita. Thank you, Rajban. Hello, Teju. Good evening. Good evening. So let's begin. When we talk about this chapter, mainly there are certain things which you need to understand. One is where we talk about what is unit, and then we slowly go to what is dimension and its applications, and then we go to the last part, which is errors, measurements, significant figures, and all those things are also there. Now, when we discuss about units and dimension, there is a thing which binds them together, and that is physical quantity. So you will see a physical quantity will have a unit, it will have a dimension. But what is a physical quantity? What is a physical quantity? A physical quantity is a quantity which can be measured. Like you can measure your height, you can measure the length of a desk, or you can measure the mass of some object, or you can measure how much time is this lecture. So all these quantities are physical quantities. How excited you are if I ask you, show it in the chat box. You cannot say it is, sir, it is 10 some random units. Or how nervous you are about the NEET exam. You will say, sir, I am 50% nervous. But 50% of what? Who is that benchmark? Who is that standard? So it's a very subjective thing. So that's why we call only physical quantities are those quantities which can actually be measured. You cannot measure happiness, sadness, etc. And whenever you have a physical quantity, let's say I call it as P, all right, that physical quantity will have a magnitude, I can call it as N, and it will also have a unit, I will call it as U. So basically physical quantity is N times of U. A physical quantity is N times of U. Let me give you a simple example so that you understand this. Let me give you a simple example. Let me give you a simple example so that you understand this. If I ask you, what is your height? Height is a physical quantity. Height is your physical quantity. I can say, yeah, my height is 5 feet. So 5 is your n. 5 is your n. Feet is your unit. I'm measuring height in feet. Similarly, how much time is this, running race going to occur, or how fast can you complete this sprint? So I can say the time taken is 10 seconds. The time taken is 10 seconds. So 10 is your number, 10 is your number, seconds is your unit. If I ask you how much is your mass, how much is your mass? Mass is that physical quantity. I can say my mass is, it is 60 kg. It is 60 kg. So 60 is your n, unit is your kg. Is that right, everybody? Everybody with me? Yep. Awesome. Very good. So now that you understand, any physical quantity will always have a number and a unit. This n is often referred to as the magnitude. Is often referred to as the magnitude, or just simply put, the value. And this u is nothing but the unit. U is nothing but the unit in which you are measuring it. There are chances that you can measure a physical quantity in many units. Like for example, the length of something is, let's say, 100 meters. I can also write it as 0.1 kilometer. 0.1 kilometer. 100 meters is 0.1 kilometers. So like you can see, my dear students, a same physical quantity can have different magnitudes, but that is in different units. So this is a very good example of that. So this is a very good example of a physical quantity can have different values of n in different units. In different units. Keep this in mind. Okay. So this is just something which you can keep a note of. Very good. Now these physical quantities, we realize they have to be measured. They have a number, magnitude, and then they have a unit. Okay. Now these physical quantities can be further classified into fundamental and derived. Remember those physical quantities? Remember those physical quantities: length, mass, time, force, acceleration, velocity, momentum, electric field, gravitational field, this, that, so many physical quantities which can be measured. But out of them, some of them are called fundamental and some of them are called derived. What do you understand by the word fundamental? What do you understand by the word derived? Fundamental means more basic. Derived means it is derived from something, right? Fundamental, like maybe, you can have water, and you might have maybe some other chemical, or, you can have some another liquid, maybe you have some orange juice. All these are, ingredients which are present in the kitchen. Maybe you have oil, maybe you have water, maybe you have some vinegar, you have some another juice. All these are your ingredients. They are fundamentally present in your kitchen. You mix them up and you cook your food. You mix them up and cook your food. You get some nice dish. So that is derived from these basic elements like water, oil, vinegar, fruit juice, this juice, that spice, that another thing. So that is the meaning of derived, where you cook something, mix it up and you get it. Fundamental is something which is more basic. Fundamental is something which is more basic, right? Everybody with me? Yep. And yes, we will be taking up many more chapters. This is just the beginning, my dear warriors. There are many more chapters to come. And the fundamental units which we have in our day-to-day life are length, mass, time. Length, mass and time. But this can be further extended to many more quantities. People realize that there are many more fundamental quantities. Don't worry about this. We'll come to it. First, people thought length, measuring the distance. Yes, that is very elementary. Measuring something mass, very basic and fundamental. Seeing how much time has passed, very fundamental. Then people realize there are many more fundamental quantities, and those fundamental quantities, which are 7 quantities, are right over here. You have mass, you have length, you have time, you have current, you have temperature, you have amount of a substance, and you have the intensity of the light. So the 7 fundamental quantities are, I'll just put it over here, mass, then you have time, then you have length, then you have current, then you have then you have temperature, then you have amount of a substance, and then you also have something called as luminous intensity. These are your 7 fundamental quantities. Any other thing in this universe, in this physical world, is dependent or derived from these fundamental quantities. Keep this in mind. They are also called as base quantities because they are very basic. Understand that. Now there is a small problem. See, we decided that there are 7 fundamental quantities. Mass, length, time, etc. Today, Pandu came to me and he said, "Sir, you know what? I am going to measure mass in, I'm going to measure it in grams. I am going to measure length in feet, and I am going to measure time in hours. That is what Pandu told me. See this beautiful Pandu? That's what Pandu told me. Then another day, Champa came to me and told, see this is beautiful Champa out here. She told me that she is going to measure mass in kg, she is going to measure length in meter, she is going to measure time in minutes." Okay. Every day one student came to me and told that they are going to measure mass, length, time, luminous intensity, temperature in different units. I got a headache that day. And which is the best pills for headache? You should only tell me. You guys are going to be future doctors. I took that tablet. I had a lot of headache. So I told everyone, listen, don't do all this. Please form some unanimous units, because imagine one person says grams, one person says kg. Imagine I have to measure density. Whether I'll use grams per feet cube, kg per meter cube, gram per centimeter cube, it is going to be very confusing. I don't like it. Please, let's stick to something. They're like, okay, we'll all decide something. And then they came up with one solution and they said, okay, listen sir, what we'll do? We will have something called as SI system. I will have SI system, and in that SI system, standard international system this is. In the standard international system, yes, very good. Somebody is saying Dolo. Dolo is for fever. Yes, one. For headache, it is, I think, that Dalt or something. Paracetamol is for fever. I had headache that day. So they decided, okay, listen, mass I will measure in kg. Okay, length I will measure in meter. Okay, time I am going to measure in second. Like that. So now it became a standard. Okay. Any person who is going to follow this system of units, they will be using mass in kg, length in meter, time in seconds. So now it became a standard. But unfortunately, our world is not so beautiful and so ideal as we imagine it to be. There was another group which was formed. They said, no, why should we accept this? We have the British foot-pound second system. This is the British, or sometimes also called as the imperial system. They said, listen, we are going to measure mass in pound, length we are going to measure in feet, and time we are going to measure in second. Thank God they agreed for time to be in seconds only. Then there was one more group CGS group, they said, no, listen, I am going to measure mass in grams, I am going to measure length in centimeters, time, I am going to still measure in seconds. I need to take one more tablet for this. But it's okay, we cannot get them to agree to each other. We in different regions of the world follow different system. Like if you go to America, they will be using pound, feet and seconds very commonly. If you are in India, you will be generally using kg, meters and seconds. But since the British ruled us for many years, there are some traces left behind. In some places you will see, like for example, when you are checking the plot size, it is measured in feet. So there are these systems. So there are historical reasons why some places, some systems are followed. Because of convention, because the rule book needs to be changed, it's too much of a task. So many reasons are there. Understood, my dear students? Very good. Hello, Imaji. Yep. So the point of the matter is that there are, different systems. Each system will measure the fundamental quantities in certain units. Okay. And there are three widely used systems. One is your CGS system, one is your British system, one is your MKS or SI system. MKS is same like SI. FPS is also your British system or your imperial system. So MKS, meter, kilogram, second, hence the name MKS, meter for M, kilogram K, second S. CGS, centimeter C, gram G, second S. That's why the name CGS. FPS, foot F, pound P, second S. That's why the name FPS system. That's why these names have come. Are you able to understand this? Everyone with me? Very good. But keep in mind, actually MKS is not exactly equal to SI system. Actually, it is not exactly equal to SI system. In the original MKS system, there were only 3 units, or there were only 3 physical quantities. When they later on added the remaining quantities like amount of a substance which is in moles, current which is measured in amperes, temperature which is measured in Kelvin, luminous intensity of light which is measured in candela, then it was called as SI system. So MKS plus the remaining units, that becomes technically your SI system of units. Keep this in mind. Okay, so a lot of people think SI and MKS are very similar. Yes, they are, but not exactly the same. MKS is only the 3 fundamental quantities, which is length, mass and time. But when you add those remaining units, which I am showing it right over here, this becomes your SI system. Is this point clear till this point, everybody? Let me know. Very good. So what and all have we learned till now? We have seen that any physical quantity will always have some number and some unit. So that's why it is generally n into u form. That number is the magnitude, unit can be anything. And you can express any quantity in multiple units. And these quantities can be classified as some basic quantities like fundamental, and those quantities which are derived from it, right, which are called as derived quantities, right? Then we saw that we try to form a uniformity, but in that uniformity also we got 3 groups, and due to historical reasons we still follow these 3 different kinds of units depending on which place you are seeing this video. So usually in India we see SI system of units. If you are in British or in America, then you might use imperial system. CGS is also used in certain regions widely. So in the SI system, you have those fundamental 3 quantities, length, mass and time, measured in meter, kilogram, second, plus the remaining units which make up the SI system, which is exactly this one. Okay, so current is a physical fundamental quantity, remember, not the charge. A lot of people get confused. They think charge is the fundamental quantity. No, temperature is measured in Kelvin. Remember, not in Celsius. Also, mole, amount of a substance, Avogadro's number. That mole is also a fundamental unit, and candela, it's a unit of light. Intensity, which we do not study in our NEET physics, is just supposed to remember only for this chapter. Okay, you will never see it. Right, very nice. Now that you understand this till here, I have listed down all the fundamental quantities, right from length to amount, their SI unit, and also their symbol. Please remember, these are nothing but your SI units. These are nothing but your SI units. This table is very, very important. Now, usually nobody will write the entire word meter or kilogram or second or ampere or Kelvin or candela or mole. They usually use a symbol, an abbreviated form. Like at home, maybe your name is, something very, very, very big. Very, 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 very big. Like for my example, my name, Shreyas. It's not that big, but decently big. Some people just call me like Shay. Like just Shay. I'm like, what? Yeah, I'm like S-A-Y or S-H-Y. Those kind of pronunciations. So that's like an abbreviated form. Or just like S, Mr. S. Or S, sir. I'm like, okay, cool. So that is like the abbreviated form over here. So meter is M, kilogram is kg, second is S, ampere is A, Kelvin is K, candela is CD, mole is MOL. Right? Great. Somebody was very lazy in this. Look at it. They thought that MOLE, they thought writing that extra letter of E is going to cost 1000 rupees, and they have to waste 1 hour in writing that alphabet E. So they just removed that E and it became MOL, and they called it the abbreviation or the symbol of it. That's how it is. Let's follow that. Okay, don't question me. Yes, very good. So somebody is saying Isha. Isha is also somebody's name. Okay, crystal clear. Very good, very good, very good. Yes, Tattva is enough, my dear warriors, for be it JEE Mains, be it for NEET. It's a very, very fantastic book. Okay, so please use that. Now, there are some amazing units of length which you should know. This is there in NCERT. That's the only reason why I'm just talking about it. Otherwise, in NEET, they don't ask such questions, but just giving you. Maybe, who knows now? The person who is going to set your paper, maybe he would have fought with someone. Maybe he fought with his wife or something. So he's in very angry mood. Who do I remove the frustration? He cannot tell anything to his wife. So he will come and say, let me select some nice line from NCERT who nobody reads. Okay, this line nobody will read. Okay, I will put this question. Now see how the students will score. But see, that person does not know that some students are learning from me also. So I will cover everything over here. So astronomical unit. Astronomical unit is basically the distance between sun and earth. So 1 astronomical unit is the distance from the sun. So this is our sun, beautiful sun. See how bright it is. Distance from the sun to the earth. Let me draw a beautiful earth over here with a little bit of blue and that green which is there, which is vegetation. Okay, so that distance, small earth, guys. Yes, so that distance is basically called as astronomical unit. Astronomical unit. I hope this is clear. Everybody with me? Yes. Definitely, Siva Prasad, you can buy the Vedantu question paper for practicing purposes. But Siva Prasad, let me tell you, there is a big surprise coming for the NEET aspirants in just next 4 to 5 days. So hold on for that. Something related to question paper, something related to mock test. A very big surprise is coming, and that is going to blow your mind. Just wait for 4-5 days. Okay, great. Next is light year. What is light year? If you are light, see, once Pandu told to Champa, you are my light, you are my sunshine. So that was the Pandu's way of proposing Champa. So Pandu told Champa, you are light. So that time what happened? Champa was traveling at the speed of light, that is 3 lakh kilometers per second. So Champa traveled, because she was light, she was Pandu's sunshine. In 1 year, she traveled 9.4 into 10 to the power 12 kilometers. She traveled so much of distance. She became so far from Pandu. Now they are in a long distance relationship. So in 1 light year, you will end up traveling this much amount of distance, because the speed of light is huge. It travels lakhs of kilometers in 1 second. So you can imagine how much will it travel in 1 year. Lot of distance. Is that right, my dear warriors? Is that right, my dear warriors? Very good, very good, very good. Next thing which you should know is parsec. Parsec. It is a distance at which this particular distance subtends an angle of 1 by 3,600th of a degree. 3,600th of a degree. Meaning, do you see this is one astronomical unit, distance between the sun and the earth. So you are over here, then you will subtend some angle. This angle is decently good. You go little bit far away, then the angle becomes even less. You go really far away. You go really far away till the time that particular angle is 1 by 3,600th of a degree. 1 by 3600 of a degree. That distance which is there is called as 1 parsec. That distance from here to here, that distance is basically 1 parsec, 1 PC. Okay, 1 PC. Is that clear? Everybody with me? Is that clear? Everybody with me? Very good. Yes, the surprise is by the team Vedantu, the team NEET warriors. Definitely. Okay, cool. So keep all these things in mind. Okay, sometimes questions can be asked. Obviously, parsec is very far. So you can see parsec is the most largest unit. 1 light year is decently big, and the smallest of them is the distance between Earth and the moon. Earth and the sun. Earth and the sun, that's the smallest of them all. And you should also know how much time does it take for light to travel between the sun and the earth. Everybody put it up in the chat box. Everybody put it up in the chat box. How much time does the light take to come from the sun to the earth? How much time does the light take from the sun to the earth? How much time do you think it takes? Keep this in mind. It's a very important value. It's a very important value. The light which comes from the sun takes about 8 minutes to reach the earth. It takes about 8 minutes to reach the earth. Keep this in mind. Very good, Aditya. Malarokri. Very good. Malarkodi, sorry. Very nice. Very good. Crazy dude also answered it. Keep this in mind. Now, apart from these 7 fundamental quantities, there are 2 auxiliary units. They are not real. They are like fake. Chumma we have added them. Like you might have seen when you play cricket or when you play some basketball or football, always there are some 2-3 people who will be sitting on the side. Please don't tell me, sir, I am one of them, sir. I sit on that bench only. I keep watching the match. I just pray to God, somebody please get injured. My turn will come, but nobody gets injured, sir. Even if they are injured, they keep playing, sir. My turn doesn't come. I feel very angry, sir. That's why I join other team. So there are 2 units like that who are not real units, but you push them into the system of units just because we want a standard. And they are plane angle and solid angle. These are like those extras. These are like those substitutes. These are like those, auxiliary or supplementary units or quantities. So plane angle is your normal angle. Plane angle is your normal angle. 5 degree, 10 degree, 90 degree, 45 degree, 30 degree. It's in a plane. So I can just take 2 points and I can measure this angle. This is in a plane. That's why it is called as a plane angle. It is measured in radian. The symbol of it is rad. The symbol of it is rad. It sounds only so cool, right? Bro, it is too much rad, bro. So yes, this is rad, radian, okay? So sounds very cool, Gen Z type kind of a, abbreviation. And the next one is the solid angle. Now this, you will not use it in NEET physics, but you should just know it. This is a 3-dimensional angle. Plane angle, plane means 2-dimensional angle. Solid angle means Three-dimensional angle. Oh my God, sir. 2D only is so difficult. 3D. So it's a three-dimensional angle that is called solid angle. It is measured in steradian and the symbol is SR. The symbol is SR. Keep that in mind. Is that right? So this is how they might look like if you try to visualize it. In general, you will see that a normal two-dimensional object will subtend some angle d theta over here or theta over here. This is an arc over here. It has subtended certain angle. And we all know that the length of an arc is the radius times the angle which is subtended. Everybody knows this. Length of the arc is the radius times the angle subtended. Everybody knows this. This is for 2 dimension. Guess what it is for 3 dimension? For 3 dimension, you need not an arc, but you need an area. Notice this particular area is subtending this 3-dimensional angle. Visualize this in 3 dimension, my dear warriors. Visualize this in 3 dimension. It's like, okay, imagine the shirt only I'm taking. Guys, this was the shirt which I was wearing before. Okay, anyways, I'm just taking the shirt. How much angle is this shirt subtending? 3-dimensional angle. Understand that. It's a 3-dimensional angle which was subtended. It is not just going to be by 2 lines. I will need 2 more lines. Okay, so that I not just 2 lines on the top but also 2 more lines here, so that I can figure out that 3-dimensional angle. And that area which I have marked over here, will now be radius square multiplied by the solid angle. That's how solid angle has been defined. This area will be the radius square multiplied by the solid angle. That's how it is. Okay, is that clear? If you are practicing few hundred questions from each chapter of NCERT fingertips, that is just okay. Make sure you are practicing PYQs also. PYQs are very, very important. If you ignore PYQs, it will be a big disaster. So practice PYQs too. Great. Let's come to derived units. We discussed all the 7 fundamental. Quantities, their SI units, their symbols. We also discussed the supplementary, the auxiliary, the additional units, plane and solid angle. Remember, they are just there for theory purpose. You will not get questions on it as such, but you might just get a direct theory questions. The auxiliary units are angle, solid angle, etc. Now, the derived units. The derived units are the ones which are dependent on all these quantities. A mixture of all these ingredients when you cook your food. So it's just like that. It's a mixture of all these ingredients. Like force. It depends on the mass calculation and also the acceleration, because force is mass into acceleration. In fact, even acceleration is not fundamental. It is also derived from something. So you can in fact make a big nice mind map. Say for example, I have the basic fundamental quantity of length and I have the basic fundamental quantity of time. So with length and time, I can get to velocity. And with velocity and time, I can come to acceleration. With acceleration into mass, I can come to force. Wow, this is nice. With force and displacement, I can go to work. Wow, this is cool. And with work and time, I can come to power. So you can see, velocity is dependent on fundamental quantities, it is a derived one. Acceleration is obviously dependent on more quantities, it is a derived one. Force is also dependent, it is also derived. Work is also derived, power is also derived. So many quantities are there which are just derived. I can also take velocity and I can just multiply it with mass and I will get momentum. Momentum is also a derived quantity. So this is how things work. When you try to identify who is dependent on what. Similarly, I can start with current, and then I can just multiply it with time. Then I will get basically charge. Current multiplied by time is basically charge. So charge is a derived quantity because current was a fundamental quantity. Keep this in mind. Similarly, I can also have units like, say for example, I have joules. I have joules per mole per Kelvin. Joules per mole per Kelvin. Out of these things, you can see mole is a fundamental amount of a substance. Kelvin is also fundamental, whereas joules is not a fundamental quantity. This is basically a derived quantity. So this quantity as a whole will also be derived. In fact, this will be nothing but your molar specific heat capacity. Molar specific heat capacity is also going to be a derived quantity. So these derived quantities are dependent on other quantities like power, energy, heat, density, velocity, force. All these are derived quantities. Is that clear, my dear warriors? Yes, potential, capacitance, resistance, all the other things, all the other names that you can think of are derived quantities. Let's see how many names that you can think of. Spam in the chat box. Spam all the names which are not there over here, which you think are derived quantities. Let's see how many names you can remember. You can put it one by one also. Resistance, capacitance, just giving you a hint. Just come on, start typing all the quantities. Let's see how many quantities you can remember, my dear students, in the chat box right away, right now. I am waiting to see your spam. Very good, very good. Keep up, keep up. Great, nice. Try to remember even from 11th, 12th, whatever. Some of you might be 11th standard students. Don't get scared if you see some strange terms. Sir, what is this, sir? Don't worry, you are going to remember. You're going to see all those things eventually in 12th standard too. Yep. Very nice. Impulse. Yes, yes, impulse. You have field, right? You have flux, stress. Very good. Magnetic flux. Very nice. Very nice. Strain too. You have modulus then, I guess. Very good. Look at that. Look at that. Try to remember all the other things. Drift speed. Wow. Very good. Amplitude. Nice. Nice. Keep it going. Keep it going. Electric field. So then you have magnetic field. Then you have gravitational field. Very nice. Density was already mentioned. Very nice. Very nice, my dear students. Force was also mentioned already. Something new. Inductance. Right? Very good. Keep it up. Frequency. Angular speed. Angular acceleration. Current density. Just think about it. Mobility, resistivity, resistance, conductivity. So many things are there. Mean free path, RMS speed, then viscosity, surface tension. Yes, so cool, so cool. Very good, very good. Potential difference, torque, angular momentum, rotational energy. Very good. So now you see there are so many derived quantities which are based on the fundamental quantities. I think it has opened up your mind. Starting off with some questions. The light year is a unit of time, mass, distance, energy. Everybody start putting up the answers in the comment section or in the chat box right away, right now. What do you think? A light year is a unit of. Yes, very good. Proud of all the warriors who are answering it correctly. It's a unit of distance. Lot of people think it's a unit of time, but I just mentioned this. Where is it? Right over here. Light year is a unit of length or distance, and that is the distance which light travels in 1 year. Remember that Pandu Champa love story. Pandu said to Champa, "You are my sunshine, you are my light." So Champa traveled at 3 lakh kilometers per second, and in 1 year she traveled this much distance. She became very far, and Pandu was in a long distance relationship with Champa after that. So that's how it is. So it's a unit of distance. It's a very, very huge unit. Very nice. C for Captain Shreyas. Newton second is the unit of newtons. Newton is a unit of force. Second is a unit of time. So Newton into second is velocity, angular momentum, energy. Just think about it. Just think about it. Newton into second. So Newton was the unit of basically force, and force was mass into acceleration. Mass is measured in kg, acceleration is measured in meter per second square. Meter per second square, right? Everybody has seen this in 9th grade itself. And into seconds is equal to 1 second will cancel. I will have kg into meter per second. Kg meter per second. Meter per second is the unit of velocity. Kg is the unit of mass. So mass into velocity, my dear warriors. Mass into velocity is nothing but momentum, right? Mass into velocity is nothing but momentum. So the answer must be C for Captain Shreyas. Very good, Seva Prasad Rupa. Awesomeness, smiling, Sarat. Study all colleagues. Shivani, very good, crazy dude. Rajban, Suresh, Jivita, very good, Madhuri. Kavya, very good, Priyadarshini. Awesomeness. Next question. The magnitude of any physical quantity, does it depend on how you measure it? Does not depend only on the measurement. Is more in the SI system than in the CGS. Is proportional to the fundamental unit of mass, length, etc. What do you think? The magnitude of that quantity depends on the method of measurement. Now, whether I take a scale to measure or whether I take, I can use something else also. Maybe I have a tape to measure, or maybe I have some another digital instrument to measure. Whatever the length is, that length will remain same, no? Whether I use my watch to measure how fast you are moving or how quickly you reached here, or whether I use a wall clock, or whether I use computer clock, or whether I used pendulum, everybody will say you took this much time. So how will the magnitude of any quantity change because you have measured it using some different instrument? Yeah, there might be error, that's another story, but how will it change? It will not change. So it does not depend only on the method of measurement. Okay, it's directly proportional to the fundamental units. No, these are all chumma given to confuse you. Other options are chumma given to confuse you. Be careful. Yes, study all colleague, it is option B. It is option B. Be careful about it. Now that you understand it till here, given any derived quantity, let me tell you, given any derived quantity, or basically forget derived quantity, I would say any physical quantity is given to you. If you know the formula, if you by chance know the formula for that physical quantity, from that you can get the units. And if you know the units, from that you can get the physical quantity. What do I mean by that? Let me give you some example. Say for example, my physical quantity is force. I know force is nothing but mass into acceleration. It's mass into acceleration. So mass is measured in kg, acceleration is measured in meters per second square. So that's it. That's the unit of force, kg meter per second square, which we call as Newton. Isn't that right? Similarly, if I know the units, also I can get back to the physical quantity if I know the formula. Say for example, I tell you the units are kg per meter cube. And I tell you the formula looks like this. Kg is in mass, meter cube is in length, so length cube. Meters per length cube, or not meters, it is mass per length cube. So kg is the unit of mass, meter cube is also the unit of volume, mass per unit volume, that will be nothing but density. That will be nothing but, my dear warriors, density. Great, keep it up. Similarly, I can tell you so many more quantities. From the quantity you can go to unit, from the unit also you can go to the quantity as well. Like say for example, I tell you, say the unit is, let's say I take it as kg meter, or let's say I just tell you it is Newton meter, and I tell you the formula is Newton is measured, is a measurement of force, and meters is a unit of displacement. So force into displacement. Oh, I know what the original quantity must be. It must be nothing but work. So if you know the formula, you can get back to the quantity. And if you know the quantity and the formula, you can derive the unit. So that's how it works. Something which you should be aware of. Very good. Now, let's talk about significant figures. Significant figures. See, often you might have wondered this, is 7.00 same as 7? Is it same as 7.0? Is it same as 7 into 10 to the power 0? Is it same as 7 or rather 70 into 10 to the power minus 1? Right? You might have wondered, are these numbers the same? Mathematically, they are the same. Mathematically, they are the same. But in physics, they are not. Physics, they are not the same. They are not technically the same. You know the reason? Because some are expressed as powers of 10, some are expressed with decimals, some where the decimal places are more, some where the decimal places are less. See, think about it. Think about it. When I just write 7, and I'm not putting decimal, that means I do not know whether it is 7.01 or whether it is 7.1 or whether it is 7.023. I'm not really sure about these. That's the reason why I'm just putting it as 7. Okay, I'm not writing it like this. I am sticking to this 7 because I'm not sure what comes after the decimal. Maybe my device only is not that accurate. Let's say some other Pandu says it is 7.00 like this. That means he has made an effort to put 2 decimals. That means he was sure till the second decimal. He was unsure of what is going to come over here ahead of this. So he was sure only till the second decimal. Only till the second decimal. So because he was sure till the second decimal, this guy was not sure even for 1 decimal. How can we say these both are equal? Because this could be anything over here in the till the second decimal. This till the second decimal I know is 0, 0. This guy has put in that extra effort. This guy has not put in that extra effort. So tell me, out of 7 and 7.00, who is more accurate? Who is more precise? Come on, my dear warriors. Yes, the value remains the same, but who do you think has put in that extra effort? Obviously, it is 7.00. Obviously, it is 7.00, my dear warriors. Obviously, it is 7.00 as compared to 7. So, this is more accurate. This is more accurate. Accuracy wise, 7.00, it's much more accurate than just 7. Very good. Excellent. Now, similarly tell me, if I put, so this is like Pandu, he got a acting role in James Bond movie. Look at this, he's now James Bond. This is Pandu as James Bond. This is Pandu as James Bond. And Pandu says, my name is Pandu 007. That's his agent code. My name is Pandu 007. Tell me one thing, in the movie and all it looks good, fine. But does this 0 carry any weightage? Does this 0 carry any weightage, my dear warriors? Think carefully and tell me. Think carefully and tell me. Obviously not, right? You will be like, Pandu, listen, did you attend Shreyas sir's class? Shreyas sir clearly told, there are some significant numbers, some are not significant. These zeros are stupid. Don't put that. So, these are completely useless. You might as well just write it as 7. So, I can just say, this 0 is completely useless, this 0 is completely useless. This is completely useless zeros. But then you know, Champa came up with a sequel, and then Champa acted in another movie. So this is Champa. And she was in another movie. And her agent code was 707. Champa 707. Champa 707. That was Champa's code name. Now tell me, will this 0 be useful or is it useless? Do you think it is having some value? Is it having some significance or no? Think carefully and answer. Because over here for Pandu, this 0 did not matter. only this 7 mattered. But for Champa, do you think apart from these 7s, will this 0 matter in her name, in her code name or not? Will it matter or not? Yes, it will. It will. In fact, this has some value, because if I skip this 0, 77, she will be like, what nonsense, my agent code was 707, you made it 77. You will not like it. So this 0 has some value. So now you see this 0 only causes a lot of trouble. Where this 0 is, how this 0 is going to decide whether it is going to be significant or whether it is not going to be significant. Did you understand? Did you understand? So what are the rules? The rules are very, very straightforward. Let's go through these rules. Very, very straightforward. All non-zero digits are significant. All non-zero digits are basically significant. So basically when we talk about significant figures, these are digits of importance. These are digits of importance. They signify the accuracy of the measurement, how accurate it is. The more the significant figures in that, meaning maybe that is more accurate. So what are the rules? The first rule says non-zero digits are significant. Zeros which occur in between are also basically going to be significant. So just to give you an example, of the first rule, if I write my number is 23516, another number that I write 178, another number that I write 107, another number that I write 1070502, another number that I write is 005, another number that I write is 0607. Okay, so in each one of them, let's identify where there are significant zeros, numbers and all, otherwise we'll just cross it out. Here all these are non-zeros, so this significant. All these are non-zeros, they will all be counted as significant. All the non-zeros are always significant. If a 0 is between two non-zero numbers, then it is significant. If a 0 is between two non-zero numbers, it is significant. 0 is between non-zero numbers, this and this are significant. All these are significant. Can you see that? And over here, this is not in between any two non-zeros, it is towards the left side. They are not significant. Even this 0 is not, but this 0 is going to be significant. So you should understand when they are significant and when they are not. So in the first case, 1, 2, 3, 4, 5. So there are 5 significant digits. 5 significant digits. 1, 2, 3. There are 3 significant digits. 1, 2, 3. There are 3 significant digits. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 significant digits. 8 significant digits. Here only 1 significant digits. 1, 2, 3. So 3 significant digits. Understood, guys? Understood the first 2 rules? Everybody with me? Everybody with me? Very nice. So these were the first 2 rules. All the non-zero digits are significant. All the non-zero digits are significant. All the zeros that occur between two non-zero digits are also significant. Zeros that occur between two non-zero digits are going to be significant. Keep this in mind. All the zeros to the right of a decimal point and also to the left of a non-zero digit is never significant. Very, very important. All the zeros that are on the right of a decimal point and also to the right of a decimal point, all the zeros right of the decimal point and also to the left of the non-zero digit is never going to be significant. What do I mean by this? Let's have a look. Let's have a look. Example, let's say 0.005. Okay, or see, understand this rule, right of the decimal point and also to the left of the non-zero digit, 0507 or 0.005. 0, 2, 3. 0.0005 0, 7, 0, 2. Look at all these numbers. Look at all these numbers. All the non-zero numbers are going to be significant. All the non-zero numbers are going to be, first of all, significant. So I'm just putting a check mark on them. If a 0 is between two non-zeros, that is also significant. This is between two non-zeros. Here also, this is between two non-zeros. This is between two non-zeros. If you look at these zeros, they are to the right of the decimal point and to the left of non-zero number, to the left of the non-zero digit. So it's to the right of the decimal and also towards the left of the non-zero ones. So all these are not significant. This is to the left of the non-zero, not significant. This is to the left of non-zero, even if it is after decimal, doesn't matter, they are not significant. Even over here, once that first non-zero number is there, to the left of it, if it is after the decimal, before the decimal, doesn't matter, they are all not going to be significant. Is this part very clear? Is this part very clear? So how many significant figures are there? 1. How many significant figures? 3. How many significant figures? 2. How many significant figures? 1, 2, 3, 4, 5. So 5 significant figures over here. 5 significant figures over here. These rules are best understood if you take examples. If you don't take examples, if you just try to by heart them, it's going to be very tricky then. Then the rules are like all zeros that are to the right of a decimal point are significant only if a non-zero digit does not follow them, okay, and contains, okay, and all the zeros that are on the right of the last non-zero digit after the decimal point are significant. So basically, I'll just tell you the main thing is all the zeros that are to the right of the last non-zero digit after the decimal point are going to be significant. After the decimal point are going to be significant. If you remember that, it's automatically going to help you with the previous one. So say for example, my number is 503.20, 29.0, 1.000, 0.07050, 0.0052040, okay, something like this. In each one of them, let's try to find out how many significants and non-significants are there. All the non-zeros are always significant, keep that in mind. All the non-zeros are always significant. Non-zero numbers over here are always going to be significant. All the zeros in between two non-zeros are always significant. So this 0 is significant, nothing here. This 0 is significant, even this 0 is significant. Cool? All the zeros before the non-zero, or even if they are after the decimal, they are not going to be significant. There is no 0 to the left. Here there are zeros to the left. So they are not going to be significant. They are not going to be significant using the previous rule. Using the current rule, if there is a 0 to the right after the decimal, if there is a 0 to the right after the decimal, that is going to be significant. This is going to be significant. A 0 after the decimal to the right of the non-zero is going to be significant. Is going to be significant. All these 3 zeros are after the decimal of the non-zero. After the decimal and after the non-zero. After the decimal and after the non-zero. They are going to be significant. But what if I just write the number like 590 or just 700? What do you think now? What do you think now? This significant, this is significant. What do you think? Is this 0 going to be significant? No, because it is not after the decimal. It is not after the decimal. So these are not significant. So please understand, 700 has only one significant figure. That's a common mistake which many students have. Is that clear? Is that clear, my dear warriors? So count over here 1, 2, 3, 4, 5. So 5 significant figures. 1, 2, 3. 1, 2, 3, 4. Here 1, 2, 3, 4. Here 1, 2, 3, 4, 5, 6. Here you have 2. And here you have just one significant figure. Is that clearly understood, my dear students? Very nice, very nice. So all these were the rules. Okay? Even that last rule was, I dealt with it. If there are zeros that are on the right side of a digit, they are significant if they come after a measurement like this, otherwise they are not significant. All these rules we have done right now. Now there is one more rule which many students do not know about. Let me explain this, very, very important. If I have something like 70 into 10 to the power 4, or let's say 0.58 into 10 to the power minus 3, or 0.0502 into 10 to the power 6. Okay, just taking some random examples, or 2 into 10 to the power minus 20 or minus 30 or something like that. Then we can also have 3.0 into 10 to the power minus 5. So powers of 10. What to do when powers of 10 are there? What to do when powers of 10 are there? Powers of 10 are never significant. So wherever you see powers of 10, just forget about it. Just forget about it. So start marking the non-zero numbers. Start marking the non-zero numbers. They are always going to be significant. Check the zero if it is there between two non-zeros. I can see one zero here, nothing else over here. All the zeros before are never going to be significant. All the zeros before are never going to be significant. So this is not going to be significant. This not going to be significant. Okay. Even a zero is not significant if it is not after the decimal. So even this zero is not significant. Only after the decimal it becomes significant. So I think this zero is significant because it is after the decimal. Here there is no decimal. Here there is no decimal. Here this zero is after the decimal. That's it. So this one has one significant figure. This has two significant figures. This has four significant figures. This has one significant figure. This has two significant figures. That's how the calculation works. That's how the calculation works. 1, 2, 4, 1, 2. Very good. Many students wrote the correct answer. Proud of you, Krishna. Puchuk, please don't spam, my dear warrior. Please put it up in the comments after the video ends. We'll have a look at it. Then imagine this. If I have a number like 70.0, okay, 70.0, and I want to write it as a power of 10. I want to write it as a power of 10. Let's say 10 to the power maybe 1. Can I convert it without changing the significant figures? Answer is yes. First, see over here, this 7 is significant. This is a 0. After the decimal, naturally it is going to be significant. Any other 0 will be significant over here. Any other 0 will be significant here. There is a reason why you have put decimal 0. That means you are sure till this decimal. So this has totally 3 significant figures. This has totally how much? 3 significant figures. Can I write it as into 10 to the power 1? The answer is yes. How do I write that? Observe. If I have to write it as into 10 to the power 1, 70 is 7 into 10. So I'll just put the number 7. Value wise this is correct. But significant figure wise this has only one significant figure. Significant figure wise it has only one significant figure. So I can put 2 more zeros over here. Now it has totally 3 significant figures. Now this is correct. Now this is correct. So please do not write this as 7 into 10 to the power 1 because this one has only one significant figure. This is not the same as that one. These two are equal. In fact, I can also put it as a negative power and see if I can write it as 10 to the power, let's say minus 2 or something, or let's say I put it as 10 to the power 4, let's say. If I put it as 10 to the power 4, let's say, can I do that? Answer is yes. I have to shift the decimal places by 4 places, then I will reach at 70. So I will put it as 0.07. Now if you notice, sorry, 0.007, 1, 2, 3, 4. So then it will become equal to 70 value wise. 0.007 into 10 to the power 4. So this decimal place will shift here, then here, then here, right? So basically 1, 2, 3 and 4 places you will see, then it will become 70. So this is value wise. But is these zeros going to be significant? Answer is no. This is not going to be significant. This is not going to be significant. This is not going to be significant. Only this 7 is. To make the significant figure same, I will have to add 2 more zeros here. Only then the significant figures will match. 3 here, 3 here, 3 here, 3 here. That's how you convert it. Is that clear? Everyone? Everybody with me? Understood? Okay. Don't worry, if you had a wrong date of birth, you can correct it later on. Hopefully, no problem will occur. Don't worry about it. Later on, we'll see. First, give the exam as it is. Don't worry about it so much. Get your date of birth corrected. Okay? Great. So, this is one common thing which many students do not know. Now, also there are some rules of rounding off. Sometimes you might need it. Rounding off. Rounding off. So, this is very, very straightforward. If you have a number like 23.2 versus 23. Let's say 8 versus 23.5 versus 26.5. I want to round it off to, two significant figures. There are 3 significant figures in each one of them. 3 digits of importance. I want to convert it into 2 significant figures. Basically, I want to get rid of 1 digit. How do I do that? How do I do that? If you look at the first example, because you want to get rid of this, because you want to get rid of the number 2, the third one, look at the previous one, and also look at the last one, the previous one and the last one. If this last digit, if it is less than 5, then do not do anything to it. Basically, don't change this digit. So this will be approximately 23 only. 23.2 can be rounded off to 23 because this is less than 5. Is this absolutely clear? Is this absolutely clear? You want to round off, you want to get rid of the digit which you want to get rid of, see if it is less than 5. If it is less than 5, then the previous digit, do not change it. That's the first rule. The next one, check the last digit. You want to get rid of this, check this last digit. Oh, it is more than 5. If it is more than 5, then this previous digit, add 1 to this. Add 1 to this. That's all. You just add 1 to this. So 23 plus 1 will become 24. So this is approximately 24. Isn't this very, very straightforward? Isn't this very, very straightforward? Very good. Now the problem comes when it is exactly equal to 5. When it is exactly equal to 5. When it is exactly equal to 5, then what to do? Then look at the previous digit. Look at the previous digit. The previous digit 3 is an odd number. The 3 digit is basically odd number. So what you do is, if it is odd, add 1 to it. 3 plus 1 is 4, so this will become 24. Always try to make it even. Do not say 23.5 is equally apart from 23 also and 24 also. Sir, it is exactly in middle, so I can write it as 23 or 24. No, always try to make it even. Always try to make it even. Same thing over here, 26.5, the previous digit is an even number. Don't do anything. Keep it unchanged. Keep it unchanged. That's it. Keep it as it is. So this will be approximately 26. This will be approximately 26. Is this very clear how to round off things? How to round off things? Everybody with me? Everybody with me? What is the number of significant figures in 0.310 into 10 to the power 3? Let's see if you guys can get it. Let's see if you guys can get it. Come on. Quickly, I want to see all the answers in the chat box. Everybody. Done, clearo, come on. 3, Pakka. Let's have a look. Yes, the correct answer is 3, because when you see 0.310, 0.310 into 10 to the power this particular 3, then first of all the non-zeros are going to be significant. The powers of 10 are never significant. Any 0 after the decimal and after the non-zeros are significant. Any 0 to the left of the non-zero, whether they're decimal or not, are never going to be significant. So this is what the count is, hence the answer is number 3. Very good. B for biology. Awesomeness. Gopika ma'am and Baswa sir will be very happy. Now, what if I tell you, listen, Pandu's mass is 60 kg, 60.00 kg. Champa's mass is 40.0 kg. Both of them are doing couple dance. Or maybe Champa is sitting on Pandu and Pandu is carrying Champa nicely here and there. So what is their total mass? What is their total mass is the question. What is their total mass? Come on. 60 plus 40. Like, sir, what do you think we are? We are some first standard kids or what? To do this 60 plus 40. 60 plus 40, we know it is 100. Okay, great, 100. But the question is about the accuracy, the decimal points, the significant figures. That's the problem. So what are we going to put here? Then similarly, I can give you something like 80.2, or maybe just let's do it over here. 8.2 minus 3.100. What do you think the answer for this will be? What do you think the answer for this will be? Crazy, right? So, whenever you have addition and subtraction, whenever you have any general addition or subtraction, what you should do is always take the least decimal place, least decimal places. So, if you see, this has how many decimal places? This has how many decimal places, my dear warriors? This has totally 2 decimal places. This has basically 1 decimal place. So hence the final answer in this situation will be just 100. The least is 1. So 100.0. 100.0, because this is the least. This is the least. So it has only 1 decimal place. It has only 1 decimal place. Is that clear? Very good. Similarly, what about the next one? 8.2 minus 3.1. 8.2 minus 3.1. Come on, let's see, what will you do? 8.2 minus 3.1. 5.1 will be there, but will there be more decimals? Will there be more decimals is the question. So 5.1 will be the answer. No, because this has only 1 decimal. This has 3 decimal. The least is this. The least is this. But by chance, I put it as 5.20 minus 3.100. Then the answer will be 5.10, because this has 2 decimal, this has 3 decimal places. Hence, I will have to put 2 decimal places over here. This is the least. This is the least over here. This is the least. So, I have to put 2 decimal places. Understood what to do for addition and subtraction? Very nice. So, it depends whether that zeros are there or not there. Accordingly, you will change the answer. Very nice. Now, what if it is multiplication and division? Multiplication and division. Okay. There were, let's say, 12 Pandus. Each Pandu had a chocolate of maybe 5.00 grams. Then when I multiply them, what is the total mass of the chocolates that the 12 Pandus have? Each chocolate had 5.00 grams. There were 12 Pandus. The total mass of the chocolate will be. So first of all, just do the basic multiplication. Just do the basic multiplication. 12 5s are basically 60. Now let's think how many decimals or significant figures to use. So whenever you have multiplication or division, it's exactly opposite. Instead of least decimal, what will you do? Instead of least decimal, this is always least significant figure. Not decimal, significant figure. Be careful about it. So for addition, subtraction, it was decimal. For multiplication, division, it is significant figure. If you notice, there are two significant figures here. If you notice, there are three significant figures here. So my final answer should only have two significant figures. My final answer should have two significant figures. In 60, this is only significant. This is not significant. So I don't think this must be the correct answer. How do I write it as the correct number of significant figures with two significant figures? Remember, that is the least amount of significant figures here. So I can write it as 6.0 into 10 to the power 1. Beautiful. So now this is significant. This is significant. I know 10 powers are not significant. So I can see this must be the correct answer. This is just the value, but this is not the correct way of writing it. This is the correct way of writing it. 6.0 into 10 to the power 1. Isn't it amazing? Because this 0, no matter what you do, will be insignificant unless you put it after the decimal. Very good. So don't put just 6.0, also put 10 to the power 1. Don't forget that 10 to the power 1, or else you will get a wrong answer. Okay. Now, I can also do some kind of division, like 12.0 divided by 3.0. 12.0 divided by 3.0. Okay. Always during multiplication and division, count the number of significant figures. This has 1, 2, 3. 1, 2. Two significant figures. This is the minimum significant figures. Just like how this was minimum significant figures. 12 divided by 3 numerically is 4. 12 divided by 3 numerically is 4. But I can't leave the answer as 4. I have to write it with two significant figures. So why not write it as 4.0? Why not write it as just 4.0? Now this number has basically two significant figures, unlike this one. So this would be the correct answer. 4.0. Is that clear? How many of you wrote it 4.0? Very nice. Proud of all of you. Cool. Let's do the further questions. Let's see if you can get the correct one. Length is 2.331, B is 2.1, then L plus B is, come on, do the math. 2.331 plus 2.1. How much it is? Just do the basic math first. That will be 3, 1 over here, that will be 4 over here, and 4. Now, whenever addition and subtraction is there, check the least decimal. There is one decimal here, there are 3 decimals here. So this is the least decimal. So this one has 3 decimal places. Obviously, you cannot use this. I have to round it off. To 4.431. 31. Come on guys, it is close to 4. So it will be just 4.4. Yes, now it has just one decimal place. Understood, my dear warriors? So the answer will be 4.4 centimeters. 4.4, D for doctor. Very good, very good. Proud of all of you, yaar. Proud of all of you. Very good, very good. Moving on to the next one. Yes, here it is. This is an example from NCERT. 5.7. I hope you are able to see this. I don't know, it has come out a little bit light, but I hope you can see this. 5.74 grams of an object takes this much volume. Express the density keeping significant figures in mind. Okay, so those of you are not able to see it properly, maybe I can just put it over here. 5.74 grams occupies 1.2 centimeter cube. Express the density in correct significant figures. Now density is mass by volume. So what is the mass? Mass is 5.74 divided by volume, which is 1.2. This was in gram and this was in centimeter cube. So first of all, divide and tell me numerical value of 5.74 divided by 1.2. How much are you getting roughly? Come on, my dear warriors. Come on, my dear warriors. So that's why I have highlighted it. 5.74, this was in grams. This was grams. This was centimeter cube. Okay. Find the density. In the PDF, it will be seen. I'll make sure that next time the screenshot is much better. Okay. Okay. So come on, think and tell me. What is the value of 5.74 divided by 12? Come on, do the division. Shift the decimal and write it as 57.4. Just say how much are you getting this as? Just say how much are you getting it as? Come on, everyone. 12 fours are 48, so it will be 4 point something. Come on, subtract 57 and 48. We'll get 9. 12 sevens are 84. You'll be left with 6. And all of that. Come on, do it. 4.78 something. Very good. Are you getting like 4.783? I think that will be recurring or something. Yeah. So over here, this will be nothing but 4.783. But the problem is the significant figures. Problem is the significant figures over here, not the decimal places, because when you divide, it's always the significant figures. This significant, this and this significant. So this is the least significant figure. So there should be only two significant figures. Only two significant figures. So 4.78, if you round it off, 4.78, if you round it off to two significant figures, it will become 4.8. 78 will become very close to 80. 78 will become very close to 80, right? That's all you need to check. It's very straightforward, my dear students. This number 8 is more than 5. So you will add 1 to the previous one. So it will become 4.8. So that is the final answer. 4.8 gram per centimeter cube. That is how you get the answer. 4.8 gram per centimeter cube. Is this clear how to solve this in-text question? Is this clear how to solve this in-text question, my dear warriors? Very good, very good. Keep it up. Moving on to the next one coming up on your screen. The area of a field is how much if the length and the breadth are given. This was asked in NEET 2022. This was asked in NEET 2022 using correct significant figures. Come on, do the multiplication. 55.3 multiply it with your 25. See what is the number you get, but then you have to keep in mind the significant figures, because multiplication always involves significant figures, not decimal places. So if you see, there are two significant figures here, so the least significant figure is 2. So final answer should also have two significant figures. In fact, out of all these, this has 4, this has so many, this has 3, this has 2. Only this one has two significant figures. Two significant figures. So I think the answer will be A only. Answer will be A. Yes, correcto. A for Ames. Very good, Yashwant Krishna, Shiva Prasad. Excellente, excellente, my dear warriors. Very good. Just one second. Okay. Next one. NEET 2020 question. Taking into account the significant figures, what is the value of 9.99 minus 0.0099? Come on. Do this. 9.99 minus 0.0099. Come on. First subtract it. Remember, for addition, subtraction, it's always the decimal places which matter. 2 decimal places, 4 decimal places. So this is the least decimal, which is basically 2. 2 decimal places are there. Come on, the final answer will also have 2 decimal places. Out of all these numbers, only one answer has 2 decimal places, so it should be option A only. You can check that. You will not even solve it. See, in the NEET exam, that's how you save time. You know the least decimal is 2, final answer will have only 2 decimal place. Look at this, 3, 1, 4. Obviously, they are eliminated. Only one answer is there with 2 decimal place. How many of you are able to solve it like this? Raise your hand, like the video. Raise your hand, like the video, quickly. Yes, very nice, my dear students, if you are able to solve it. Otherwise, you have to subtract them and all that, and then you will get the answer. Like this will be, you borrow the ones and all of that, and then you will get the answer, right? So that is going to be much more difficult. Like this will be 1, this will be 0, this will be 8, and this will be 9, and this will be 9. So then you approximate it to 2 decimal places. This will be 9.98. 9.98. So that is the answer over here. Now let's go to dimensions. Now that you are clear with significant figures, rounding off, how to add and subtract numbers and multiply and divide them. So it's time to talk about dimensions. And let me tell you, many teachers and many students do not know or explain or learn the correct difference between dimension and a unit. And often that confusion happens. People think dimension is unit, unit is dimension. Very good, Siva Prasad, if you solved it like that. Very good, Krishna, you also solved it like that. Sarath also solved it. Yes, integration derivatives also I will do it for maths. Definitely. Why not? So, my dear students, meaning of dimensions is that you can express any quantity, be it fundamental or derived, in terms of the fundamental. In terms of the fundamental, by raising it to appropriate powers. Example, velocity. I know velocity is a derived quantity. Velocity is a derived quantity. Even force is a derived quantity. Everybody with me? Can I express it in terms of fundamental quantities? The answer is yes. Like velocity is distance, or sorry, not distance, it is displacement by your time. Displacement is basically having, or rather it is measured in meters. So the fundamental quantity which measures the displacement is length. So it is basically length. Right? Time is measured in time only. It is just time, but it is below. I'll just try to bring it up because that's how you always express dimensions. And when I bring it up, it will become -1. The power of length is +1. The power of length is +1. So the dimension of velocity will then become length raised to 1, t raised to -1. Because velocity is measured with displacement and time. Displacement is measured in length. Time is measured in seconds, or it's the fundamental quantity to measure time is time itself. So it's already fundamental. So when you bring it on the top, it will become raised to negative power. So length raised to 1, time raised to -1. But whenever you express dimension, always make sure you put it in square brackets as a convention, as a rule. That's all. So whenever square brackets come, means you are talking about dimension of that quantity. Dimension of that quantity. So the dimension of velocity is length raised to 1, t raised to -1. Is that clear, my dear warriors? Is that clear, my dear warriors? Similarly, force, can I write it in terms of fundamental? Yes, it is mass multiplied by acceleration. Now, mass is mass only, no problem. Acceleration, I can write it as velocity divided by time. Velocity divided by time. Mass, the symbol for mass is m, and the power of mass is 1. Velocity, I can write just from here as length raised to 1, t raised to -1. Length raised to 1, t raised to -1. The whole thing divided by time. The whole thing divided by time. Bring it on the top. it will become m raised to 1, L raised to 1, T raised to minus 2. Minus 1 and minus 1 will become minus 2. And whenever we have to write dimensions, I told you, always use square brackets. Always use square brackets. So the dimension of force will be m raised to 1, L raised to 1, T raised to minus 2. So if you know the formulas, it becomes very, very similar, very, very simple. Is that okay? Everyone with me on this? Clearo, clearo, clearo. Very good. Very good. So let's take more examples of dimensions so that you understand it better. Let's say I ask you the dimension of density. I ask you the dimension of density. Ask you the dimension of density. You will be like, okay, density is nothing but, sir, it is nothing but, Shreyas sir says it is mass by volume. Mass by volume. But mass is fundamental, volume isn't. Try to convert it into fundamental. Try to convert it into fundamental. So it is mass by volume is side into side into side. So it is basically the cube of the length. It's basically cube of the length. Symbolically, it is m by L cube. But always bring the powers on the top. And even if the power is 1, write it. M raised to 1, L raised to minus 3. So that is the dimension of density. M raised to 1, L raised to minus 3. Very good. Excellent. Similarly, if I ask you what is the dimension of work? What is the dimension of work? You will think, sir, the formula for work is force and displacement multiplied. So it is force multiplied by displacement. But sir, just some time back you told me the dimension of force. The dimension of force. Oh, so I can do one thing. I can just take the dimension of force and also multiply it with the dimension of displacement. The dimension of basically displacement. Okay. So the dimension of force from the previous slide was m1 L1 T raised to minus 2. m1 mass raised to 1, L raised to 1, T raised to minus 2. Yes. And the displacement is measured in length. Length means L raised to 1. So solving this, I will get m raised to 1, L raised to 2, T raised to minus 2. That's the dimension of work. So what do you understand from these examples? What do you understand from these examples? If you know the formula, you can find the dimensions. You can basically find what? The dimensions. Isn't it very straightforward, my dear students? So say for example, I tell you current density is nothing but current by area. Current density is current by area. Find the dimensions of current density. What will you do? You will like, it is the dimension of current upon dimension of area. Dimension of area. Dimension of current. Symbolically, dimension of current, this is basically your current. Dimension of current symbolically is A, and dimension of area, length square, so this is L square. So this is A raised to 1, L raised to minus 2. A raised to 1, L raised to minus 2. As simple as that. Similarly, somebody tells me specific heat capacity is the heat divided by the mass multiplied by the temperature. Specific heat capacity is nothing but the heat per unit mass per unit rise in the temperature. And now they ask you find the dimensions of specific heat capacity. No issues. What will it be? It will be dimensions of heat divided by dimensions of mass divided by dimensions of temperature. What is the dimension of heat? Heat and energy, they are having the same dimensions. Heat is having the same dimensions as energy because they are having the same unit. In fact, it has the same dimension as work also. It has the same dimension as work. Heat, energy, work, all same unit, same dimensions. So my dear warriors, sometime back only I found the dimensions of work, m1 L square t raised to minus 2. So it is m1 L square t raised to minus 2 over here. Mass is nothing but m raised to 1, and length, temperature is K. Temperature is basically K. The symbol for temperature's dimension is K. So shift it. m1 cancels. You have L square, you have t raised to minus 2, and you have K raised to minus 1. So that is the dimensional formula for specific heat capacity. Specific heat capacity. Understood, my dear warriors? Very good. Now tell me, if you know the unit, can you find the dimension? I think so. Say for example, the unit of a physical quantity is given, and can you find the dimension? The answer is yes. The answer is yes. How? Let me show you. Example, the unit is given. Gram square per ampere Kelvin cube. This is the unit. Another example, meter square into ampere per meter square into ampere per kg's root. What is the dimension? What is the dimension going to be? Let's have a look at it. Gram is mass, so it is basically m raised to 2. Ampere is current, so it is current raised to 1. Kelvin is temperature. Temperature symbol is K, so raised to 3. So the dimensional formula will be m raised to 2 into ampere raised to minus 2 and Kelvin raised to minus 3. M square A raised to minus 2, K raised to minus 3. Very good, Silver Lake. Awesomeness. Here, meter square. So basically you have length square. Okay. Ampere, that's basically current. So A raised to 1. Whole thing divided by root of kg. So that's root of mass. So that's the root of mass over here. When you take it on the top, this is how it will look like. M's power is actually half. Technically, this is m raised to half. When you take it on the top, it will become m raised to minus half, L raised to 2 and A raised to 1. So that will be the dimensional formula. That will be the dimensional formula. Is that clear? Is that clear? Oh, sorry, it was A raised to minus 1. I don't know why I wrote minus 2. So sorry. This is minus 1. Yes, sorry. A raised to minus 1, K raised to minus 3. Correct. Everybody with me? So if you know the units, you can find the dimension. If you know the units, you can find the dimension. Not just that, if you know the formula also, you can find the dimensional formula of any quantity. Okay, so that's what it is. Now, is it possible that there are two quantities with same unit and same dimension? That's the question. Can two physical quantities have same unit and dimensions? That's the question. What do you think the answer is? Can two quantities have the same unit? Think logically. Can two quantities have the same dimension? Think carefully. Two physical quantities, can they have the same unit? Think, my dear warriors. Think carefully. Can they have the same unit? Can they have the same dimensions? Figure it out. Okay, I'll give you an example. Speed and velocity. What's the unit of speed? Meters per second. What is the unit of velocity? That is also meters per second. Don't they have the same unit? Aren't they two different physical quantities? Don't say, sir, speed and velocity is same. One is scalar, one is vector. No, they are two different quantities. 100% they have the same unit. Forget that. Let's talk about impulse. And let's just talk about momentum. What's the unit of momentum? It's kg meter per second. What's the unit of impulse? That is also kg, meter per second. But they are not the same thing. They are two different physical quantities, but their units are same. 100% it is possible. And when units are same, even the dimensions will be same. If they have same unit, obviously dimensions will be same only. So both of them will have the dimensions of meters per second. That means length raised to 1, time raised to -1. So that is also same. This is mass raised to 1, length raised to 1, time raised to -1. So the answer to this question is yes. The answer to this question is yes. Very good. Work, energy, so many things. So many things. Yeah, whatever I am going to teach this week will be the portion in the mock test. Whatever any teacher teaches in the week will be the portion for the weekly mock test. Keep that in mind. Then, tell me my dear students, can a physical quantity have two units or basically have multiple units or dimensions? Is this possible? Can a physical quantity have more than one unit and more than one dimension? Well, let's take that example. Let's take an example. Let's say we take the unit of acceleration. Acceleration has the unit of meters per second square, or I can also use centimeter per second square, or I can also use kilometer per hour square. All these are units. All these are different units of acceleration. Or take the example of just simply length. Length is also a physical quantity. I can use meter, or I can use feet, or I can use kilometer. So many units. Definitely. So this is possible. It can have multiple units. But what about dimensions? Acceleration has a unique dimension. It has the dimension of length raised to 1, t raised to -2. Length has a dimension of L raised to 1. There is no doubt about it that it can have only a one single dimension. Is that right? Everybody with me? Very good. So that's the difference between units and dimensions. I hope now it is very clear. What is the meaning of unit? What is the meaning of dimension? Can two things have same unit? Can two things have different dimension? All these are different things that you should work upon. Okay, one more thing which reminds me is when we talk about, this is very famous example, work and torque. Do they have the same unit or do they have the same dimension? Come on, think about it. Work and torque. Work, formula wise, is force multiplied by the displacement, and torque, formula wise, is the position multiplied by the force. Position of the force into the force. So if you look at it dimensionally, force dimension into displacement the dimension, which is length. Position's dimension is length. Dimension of force is F. So technically what I will get is both are same. In fact, the dimension of force was mass raised to 1, L raised to 1, t raised to -2, and into the length. So it will end up being m raised to 1, L raised to 2, t raised to -2. That's the dimension of torque, and that is going to be same. Both for torque as well as for work. But unit wise, that's a problem. There is a problem. Work is expressed in joule. Torque is not expressed in joule. This is meter, this is Newton. It is expressed in Newton meter. This, although 1 Newton into 1 meter may be 1 joule, but the units they use are different. So we use different units. They are different. Although the dimensions are same, the units used may be different. Like the best example is this one. Yes, very good. Is that clear? They have the same dimension, but they have the different units. Keep this in mind. Which of the following is not equal to watts? Watt is a unit of power. Watt is a unit of nothing but power. Power is nothing but work divided by time. Work divided by time. Oh my God, look at it. Work divided by time. You should be able to get this, my dear students. Very, very simple. Very, very simple. This is joules. Joules is work. Second is basically time. So work by time is power. Yes, that is correct. So this is correct. Which of the following question says is not equal to? Is not equal to. Ampere into volt. Current into voltage. Voltage into current is also electrical power. Voltage into current, VI. I squared R, ohm is resistance, is also electrical power, definitely. Ampere by volt, no. I by V doesn't come out to be anything. I by V doesn't come out to be power, so definitely this is not power. So hence it is the odd man out here. So that is answer D. That is answer D. D for doctor. Very good, very good, very good. Proud of all of you. Moving on to the next one coming up on your screen. Which of the following does not have the dimensions which are equal? Energy and torque. I just discussed this. Energy and torque both have the dimensions m raised to 1, L raised to 2, T raised to minus 2. Because energy, work, same thing. Force into displacement. This is R into F. Same dimension. Modulus of elasticity and pressure, you will see that they also have the same dimension. Pressure is force per unit area. Modulus of elasticity is stress by strain. Strain is completely dimensionless. Strain does not have any dimension. But stress has the same dimension as force by area. Force by area, which is just like pressure. So that is also having the same dimension. If you look at angular momentum and Planck's constant, my dear warriors, what do you think? Many students are saying B for Baswaraj sir, B for biology. Wow, look at that. What do you think? Angular momentum, it has mass into velocity into r. So dimensionally it will be m raised to 1, L raised to 2, because velocity is, okay, if you want I'll write it like this, length raised to 1, T raised to minus 1 into length, which will make it m raised to 1, L raised to 2, T raised to minus 1, So that was for angular momentum. For Planck's constant, so for Planck's constant is energy by frequency, or F. Energy had the dimensions of m raised to 1, L raised to 2, T raised to minus 2. Dimensions of frequency is 1 by time. When it goes on the top, it will multiply and it will become m raised to 1, L raised to 2, T raised to minus 1. So these both are equal. Hence C option is also equal. Obviously the wrong option is option B. Because force is m raised to 1, L raised to 1, T raised to minus 2. And impulse is m raised to 1, L raised to 1, T raised to minus 1. Just like momentum. How am I able to write these dimensions so quickly? Because I know those formulas by heart. Not for dimensions, but formula for force and impulse. So quickly I think. Force is mass into acceleration. Mass is m raised to 1. Acceleration is L1 T raised to minus 2. Impulse, momentum, same thing. Momentum is mass into velocity. Mass is m raised to 1. Velocity is L1 T raised to minus 1. So that's how I'm able to write it quickly. So don't get intimidated or scared. That's answer B. Moving on. The dimension of Planck's constant, I just did this. See, this has been repeated. This was repeated in AIPMT 2000 and also 2001. I mean, they repeated it just next year. The dimension of Planck constant is equal to, we just did this, both are equal. Who? Angular momentum. Planck's constant and angular momentum, they both are equal. We just did it in the previous slide. Over here. m1 L square T raised to minus 1. m1 L square T raised to minus 1. That's the dimension of both of them. They are equal. Yes, angular, where is it? Angular momentum. Is that right, everybody? I hope you are smashing the like button and also subscribing to the channel as we are watching this video. Next question. If you know the formula, you can find a dimension. If you know the formula, you can find a dimension. The dimensional formula of thermal conductivity, I'll give you the formula. That is nothing but heat flowing per unit time is thermal conductivity K into area into temperature difference, the whole thing divided by length. So this is your thermal conductivity. So rearrange, you will get the answer. So thermal conductivity is dimensions I want to find. So for that, thermal conductivity will be heat flowing per unit time multiplied by length, whole thing divided by area multiplied by the temperature difference. So when I want to find the dimensions of this, I will also try to find the dimensions on the RHS. So that will be equal to, heat is just like energy is just like work. So heat and work have the same dimensions. So it will be m1 L square T raised to minus 2. Time is T raised to 1. Length is L raised to 1. Area is L square. Temperature is K raised to 1. That's it. Solve it and you will get the answer. Solve it. M raised to 1 will remain. L square will get cancelled. L raised to 1 will be there. T raised to minus 3 will be there. Just check it if it is option A. M1 L raised to 1 T raised to minus 3. Yes. You should get M1 L raised to 1 T raised to minus 3 and temperature raised to minus 1. That should be the answer. Straightforward if you know the formula. A for AIMS, very good. Many of you are going to AIMS. Very good, Krishna. Study all colleague. Rachel, very good. Rupa, very good. Kalesh, very good. Maswat, very good. Krishna, Shivani, very nice. Moving on to the next one coming up on your screen. The dimensions of gravitational constant, AIPMT 2004 question, can be repeated in NEET also in many different ways. So gravitational force is G mass 1 into mass 2 divided by r square. So gravitational constant is force into r square divided by mass 1 into mass 2. So when I find the dimensions here, I'm also trying to find the dimensions here. That's all. So dimensions of force is mass into acceleration. So m1 L1 T raised to minus 2. Dimensions of length is L, so raised to 2. Whole thing divided by m1 m2. So m raised to 1, m raised to 1. So it will become just m raised to 2. Right? That's what it will become. Check it out, everybody. So m's power will be -1. That's one thing. So automatically I will choose D option. Automatically I'll choose D option just by looking at only the dimension of m. M's power will be -1. Even if I don't calculate the others, this should be true. So it will be m1 L cube T raised to minus 2. Right? L1 into L square is L cube T raised to minus 2 as it is. So that's option number D for doctor. Cool. Shall we go to the next part, which is applications? Shall we go to the next part, which is nothing but applications? There are 3 applications of dimensions. One is to check if some equation is correct or wrong. And this can be actually used to eliminate options. This can be used to eliminate options in multiple correct questions or MCQ exams, objective exams. So I would say in basically options in objective exam. So maybe it's not a value question, maybe it is a formula question. The mass of something is m, it is moving with this speed, after what distance will it stop? So you know, the question is saying at what distance will it stop? So final answer should have the dimensions of distance. That's all. Just check which option has the final dimensions of distance. So it is used to verify the correctness of the physical equation. Sometimes you might have to derive a relationship between one thing and the other thing. You are seeing all the options have velocity, distance, time, everything. Okay, you need to find a formula. You don't know how to solve it. Dimensional analysis helps you get the final answer without actually solving using physics. You can derive a formula in certain cases. It also is useful for converting one quantity units into other quantity units. Just 1 second, guys. My throat is drying up. Water has finished. 1 second. Yes. Good evening everyone. So we have more 1 hour worth of class. That's it, not more than that. So dimensional analysis, like I was saying, can be used to check certain answers, certain relations, certain equation if they are correct or wrong. Second is to find a formula without actually using physics. Third one is to convert units. We'll see all the applications in detail. Don't worry about it. Starting off with how to verify whether some equation is correct or wrong. Maybe a question says, maybe there is a question which says find the distance after which it stops, and maybe one of the options which are there says something like 3v0 square by 2g, 3v0 square by 2g, and one of the other options says, this is one of the option, and another option says it is 5v0 by 2g square, something like that. Now I don't know which of these options are correct. I don't want to solve it, but without using physics I can get the answer. I know it is one of them, I know others are wrong, but I know one of them is correct. How do I choose between them? Observe this. What does the question say? What does the question say? What is the final distance traveled? Some nonsense is there. Distance means length. So the answer should have the dimension of length, right? Answer should have the dimension of length, right? Okay, observe. 3 by 2. 3 is a dimensionless number. 2 is also a dimensionless number. Ignore it. V0 square. So V is velocity. So velocity's unit is, dimension is L1 t raised to minus 1. But I square it. And bottom I have gravity, acceleration, so that is meters per second square. That is what this is. Here 5 and 2 ignore. V0 is on the top, so L raised to 1 t raised to minus 1. G, acceleration due to gravity, is below, so L raised to 1 t raised to minus 2 whole square. Now solve them and see what do you get. This will become L raised to 2 t raised to minus 2, bring them on the top, it will become L raised to minus 1, L raised to minus 1, t raised to plus 2, t raised to 2, t raised to minus 2 cancel, this will become basically L, and over here this will become L raised to 1, t raised to minus 1, this will go on the top, become L raised to minus 2, t raised to minus 4, so this will become L raised to minus 1, t raised to minus 5. Wow, it is very clear who is wrong and who is correct. Obviously this is wrong. You will definitely eliminate this option, and the option that you will select, because this is matching with the original question's dimension, you will select this. So you can check the dimensional correctness. Understood? Understood? So when you check the dimensional correctness, what it also means is you are using something called as homogeneity. Homogeneity, meaning whatever is there on the left hand side and whatever is there on the right hand side, the dimensions are equal. Homo means same. Homogeneity of dimensions means the dimensions on left hand side and the right hand side are equal, and that's how you are able to establish the correctness of the equation. You are able to establish the correctness of the equation. Is that clear? Now understand this. If I tell you, listen, v is equal to u plus acceleration into time, is this dimensionally correct? Is this dimensionally correct? Okay, let's do one thing. Velocity is length raised to 1 t raised to minus 1. Initial velocity is also length raised to 1 t raised to minus 1. Acceleration is length raised to 1 t raised to minus 2 into time. Okay, so this will become nothing but L raised to 1 t raised to minus 2 plus 1 is minus 1 t raised to minus 1. Okay, so L raised to 1 t raised to minus 1, L raised to 1 t raised to minus 1. That's what I get. Now check this out. U is this, AT is this. I am adding similar dimensions and I am seeing on the left hand side I am getting the same dimension. So this plus this is this. LHS has same dimensions. I am adding and subtracting with similar dimensions. So there is nothing wrong with this equation. So this is correct. So this will be the correct equation. You are checking it dimensionally. You are checking it dimensionally. Is that right? Everybody with me? Is that right? Everybody with me? Very, very, very good. But what if somebody says, let me just duplicate this, and somebody says, listen, V is U plus 480. V is 2U plus 480. Something like that. V is 2U plus 480. Then also this equation will remain same because 2 and 4 are dimensionless entities. Then you will think, sir, but V is not 2U plus 480. Although dimension wise this is matching, but equation wise this is wrong. No? Equation wise V is U plus 80. It is not 2U plus 480. So what does this tell you? What does this tell you? This tells you that if a equation is correct physics wise, then it must be dimensionally consistent. It must be dimensionally consistent, meaning this is correct in physics. 100% the dimensions on LHS and RHS must be equal. No negotiation on that. This is non-negotiable. But if an equation is dimensionally consistent, then the equation may or may not be correct. May or may not be correct in physics. In physics, they may or may not be correct. Like this one is not correct. Is that understood, my dear warriors? The difference between the two? Is that understood, my dear warriors? Pakka? Clearo? Alright. Look at this. This is there in NCERT exercise 1.3. Half mv square is mgh. Then can you check whether the equation is dimensionally correct or wrong? It's very, very straightforward. It's very, very straightforward. Start with the left hand side. It is basically half mv square. So when you check the dimensions here, you have to check the dimensions of half mv square. Half is a dimensionless number, ignore it. So you just take the dimensions of mass and velocity square. Dimension of mass is m raised to 1. Velocity is L raised to 1 t raised to minus 2, square it. So it will be m raised to 1, L raised to 2, t raised to, sorry, not minus 2 guys, minus 1, my bad, t raised to minus 1. So t raised to minus 2, that's what it is. This is your left hand side's dimensions. Similarly, try to find your right hand side, which is mgh, dimension of that. Mass has a dimension of m raised to 1. Acceleration is length raised to 1, t raised to minus 2. H is length raised to 1. Height is length, so length raised to 1. So this will become m raised to 1, L raised to 2, t raised to minus 2. This and this are same. LHS and RHS are basically the same dimensionally. So yes, this is dimensionally correct. Hence, this is dimensionally correct. LHS and RHS are same. Hence, it is dimensionally correct. Is that understood? Yes, very good. Very good. Moving on to the next one coming up on your screen. This question is directly based on the previous one. Okay, so I'm not going to discuss it again. Example 1.4 is same question, like the kinetic energy, okay, is which of the following formulas. Only one of them is dimensionally correct, and you will see that dimensions of option B are perfectly matching over here. Other dimensions will not match. So only dimension of B will match. None of the dimensions will match. It's completely based out of exercise 1.3 question. Okay, so I'm just putting it over here because that was important. Now, next thing is to derive a relation between two quantities, and that's very straightforward. Let's see how to do that. Okay, so whenever you know that a quantity P depends on other quantities like P1, P2, P3, etc. P1, P2, P3, etc. And very important, the formula is not having log or some trigonometry or exponential or addition or subtraction. All these things are not involved. The formula is not having any of these things. Logarithm, trigonometry, exponents, additions, or exponents means e raised to something. Then you can say that the quantity P is some constant into P1 raised to alpha, P2 raised to beta, P3 raised to gamma, and so on and so forth. And then you can also say the dimensions of P is dimension of P1 raised to alpha, dimension of P2 raised to beta, dimension of P3 raised to gamma, so on and so forth. This is also assuming this constant is dimensionless. Otherwise, you need to know that also. Dimensionless. This is dimensionless. Only then you can use this method. Otherwise, you are forced to derive it using physics. So what you will do is, you will say that if this is dimensionless and this is not trigonometric, exponential, logarithmic, then it will be a simple relationship. P is P1 raised to alpha, P2 raised to beta, P3 raised to gamma into some constant. So the dimensions should match. So these dimensions will match. LHS will be equal to RHS, and solving you can get the value of alpha, beta and gamma, and so on and so forth. Whatever other variables are, you can find all these values, so you will know the correct formula for that. So let's try to understand this with an example. Let's try to understand this with an example. Exercise 1.5, it says there is a pendulum having a bob attached to a string which oscillates due to gravity. Length is given, mass is given, acceleration is given. Find the time period expression using this method. So we have a pendulum, we have a mass, we have the length, this is the hinge point, and we know acceleration due to gravity is like this. So as this pendulum goes back and forth like that, what is the time period of the oscillation? So first thing I realize that the time period is dependent on who all things? Mass, length and gravity. So T is P, M, L, G are P1, P2, P3. Time is P, P1, P2, P3 are nothing but your mass, length and gravity. So I can just say time period is some constant into mass raised to alpha, length raised to beta and gravity raised to gamma. If you don't like alpha, beta, gamma also, you can use x, y, z also. Length raised to y, g raised to z. No harm in that. So, dimensionally speaking, dimension of time period will be dimension of mass raised to x, dimension of length raised to y, dimension of g raised to z. Okay, this is time period, so dimension will be t raised to 1 only. This is mass, so this is m raised to 1 only. This is length, so this is l raised to 1 only, right? And this is acceleration due to gravity, so it is l raised to 1, t raised to -2 meters per second square raised to z. Rearrange it to write it in a slightly better form. There is only one mass term, so m raised to 1 raised to x, meaning m raised to x, l raised to y, l raised to z. So L raised to y plus z. Time power is only -2z. -2z. That's all. So this is how the equation looks like. Now, if you see on the left hand side there is time, there is mass, length and time on the right hand side. The power should match. Whatever is on the LHS should match on the RHS. The powers should also match. But I know you are wondering, sir, there is no mass only over here. Actually there is, but you have to look little bit deeper. Technically, the mass's power is 0, the length's power is also 0. Mass power is also 0, length's power is also 0. So if you use that analogy, then you will see 0 is basically x. 0 is basically x. For length, 0 is basically y plus z. And here for time, 1 is equal to -2z. Therefore, z will be -1/2. If z is -1/2, from here y is minus z, so it is minus of -half, so it will be +half. So y is basically +half. Okay, so what is the final formula then going to be? The final formula is going to look like this. Time period will be constant into mass raised to x, x is 0. Mass raised to x, x is 0. Length raised to y, y is half. Gravity raised to z, z is -half. Gravity raised to z, which is nothing but -half. Okay, so this will be constant. M raised to 0 is nothing. Length's power is half, so root of L. And g's power is -half, so root g below. So time period will be some constant root L by g. Time period is some constant root L by g. That's the answer. Understood how to solve this, my dear students? Okay. So, like I said, the first step, I'll revise, I'll recap, I'll do summary. You assume the quantity is dependent on certain things. Here, time is dependent on certain things. And assume the formula. Assume the formula. Some constant into some powers. Some constant into some powers. Unknown powers. Then the dimensions on left hand side and the right hand side will be equal. Constant has been assumed to be dimensionless. Okay. Now, when you write the dimensions of each of them, you will see you can merge some things, you can raise to some things, you can combine them and make it look like a simple formula. Now, whatever is there on the LHS and RHS, the power should be equal for mass, for length and for time. Just write 3 equations, 3 unknowns, solve it, you get the value of x, y, z. Once you get the value of x, y, z, put it here, you get the final formula. You get the final formula. Cool? Let's do some questions also on this after some time. Yeah, the answer is correct, no problem. Last one is converting one unit into other. The logic over here is any physical quantity, since is number into unit, therefore in many units or multiple units, n1 u1 will be n2 u2, which will be equal to n3 u3, so on and so forth. But the physical quantity will remain the same. Just to give an example, if I say the length is 1 centimeter, it is as good as saying it is 0.01 meter, which is as good as saying it is 10 millimeters. Notice u1 is centimeter, u2 is meter, u3 is millimeter. n1 has changed, n2 has changed, n3 has changed. So the product will remain the same. 1 centimeter is same as 0.01 of a meter which is same as 10 millimeters. So that is the logic which is generally used for converting, but there are many easier ways also to convert, which I will be showing you now. So for example, the CGS unit of force is dyne, whereas the SI unit of force is Newton. So 1 Newton is how many dynes? Simple question, but let's try to do it in a very simple manner also. 1 Newton is how many dynes? Now 1 Newton, if I want to convert it into dynes, the first step, my logic says, is to remember or just try to recollect or derive the dimensions of force. What is the dimension of force? Quickly think about it. What is the dimension of force? Mass raised to 1, length raised to 1, t raised to -2. That's the dimension of force. So when I will write 1 Newton, it will have the unit of mass, kg, and time in this manner, like this. Kg raised to 1, length is meter, meter raised to 1, second raised to -2. Is that right? Kg meter per second square. This is as good as saying kg meter per second square. Kg meter per second square. Now these are all fundamental units. Kg, meter and second. Aren't these fundamental units which are SI units? Write it in CGS form. That's all. Very simple. Write it in CGS form. 1 kg is how many grams? From SI to CGS I am going. 1 kg is how many grams? It is 1000 grams. 1 meter is how many centimeters? It is 100 centimeters. 1 second here and 1 second here is the same. So it is just second square. Okay. So 10 to the power 3, 10 to the power 2 will make it 10 to the power 5 gram centimeter per second square. Oh, gram centimeter per second square will be exactly dyne. So this will be 10 to the power 5 dynes. Isn't this much better? 1 Newton is 10 to the power 5 dynes. We got it by first writing the dimension, then writing the entire formula in fundamental units, and finally convert each fundamental unit and get the answer. This is much easier. Much easier. Do you guys agree with this? Very good. So, oops, what just happened? Let's solve some questions. AIPMT 2011 question. Density is this in a system of unit where the unit of length only is 10 centimeter, unit of mass is 100 gram. The value of density of the material in that unit will be. Okay. So we have a CGS unit and we have a new unit. So in that new unit, one unit of length is 10 centimeter and 1 unit of mass is basically 100 gram. So if I ask you 1 centimeter will be how much length? One length is 10 centimeter. 1 centimeter will be how much length? 0.1 unit length. 0.1 unit length. Everybody agrees with this? 0.1 unit length, 1/10 of it. If 100 grams is 1 unit of mass, 1 gram will be how much? It will be 0.01 unit mass. 0.01 unit mass. Everybody with me? Okay. The question is on density. You should know the dimensional formula just like I did it over here. Always know the dimensional formula. What is the dimensional formula? Density, mass by volume. So m raised to 1, L raised to -3. So I can just write it as m raised to 1, L raised to -3. That's the dimension of density. So starting off with the value of the density of the material will be, okay, so 4 grams per centimeter cube. Observe this now. M is on the top, length cube is below. Yes, perfectly matching. Dimensions are perfectly matching with the units, no problem. 1 gram is how many unit mass? 1 gram is how many unit mass? It's 0.01 unit mass. Unit mass. But before that, the number 4 also should be there. So just let me put that number 4. 4 is there as it is, multiplied by 1 gram is 0.01 unit mass. Very nice. Whole thing divided by centimeter. 1 centimeter is 0.1 unit length. So 1 centimeter is 0.1 unit length. And that has to be cubed. That has to be cubed. So what will this become? 4 into 10 to the power minus 2 divided by 10 to the power minus 1's cube, which is minus 3. So this is unit mass divided by unit length cube. So what will this be? This will become 0.4 unit of density. Mass by length cube is density, unit of density in that new unit. So how much will it be? 0.4, which is option number, I think the answer given over here is wrong. Yeah, it should be 0.4. Everybody with me? Just check it out. Oh, sorry. My bad. I did a mistake over here. My bad. It is 40 only. So this is equal to nothing but 4 divided by 10 to the power minus 1, which is 40. That will go on the top and it will become 10 to the power 1. Yeah, 40 unit of density. 40 unit of density, because mass per length cube is the unit of density, which is option C for Captain Shreyas. Yes, that's it. Straightforward. Everyone, shall we go ahead? Understood how to solve these questions of converting from one unit to the other? Let's do more problems. Don't worry, it will come. Velocity of a particle is given by this some random formula. A, B, C are constants. The dimensions of A, B, C are. Okay, straightforward. You can only add similar dimensions or subtract similar dimensions. So if you notice over here, I'm adding I'm adding 80 to something to get V. So 100% the dimension of velocity will be the same as the dimension of 80. Will be same as the dimensions of 80. Okay. So basically dimension of A into dimension of time, which is T, will be dimension of V, which is length raised to 1, T raised to minus 1. So how much will be the dimension of A? Think about it. It will be L raised to 1, T raised to minus 1, whole thing divided by T. So it will be L raised to 1, T raised to minus 2. So that's for A. That's for A. That's for A, right? That's for A. L raised to 1, T raised to minus 2. Cool. Now coming back over here. If you notice, C is added with T. That means dimension of C must be equal to dimension of T. That means dimension of C is T raised to 1 only. Dimension of C will be same as the dimension of time. Because this by this is V dimensionally. So can I not say dimension of V will be dimension of B divided by dimension of T plus C. So V's dimension is L raised to 1, T raised to minus 1. Dimension of B I don't know. This is having dimension of time. So the dimension of B will be this into this. So it will be just L raised to 1. L raised to 1. So is it there somewhere? Is it there somewhere? Yes, LT and LT raised to minus 2. Yes, LT raised to minus 2 is there. L is there and T is over here. A, B and C. Done, done. Dusted. Very nice. Understood, guys? Very good. Moving on. Next question. The potential energy is given as a function of X. Okay, A and B are constants. What's the dimension of A by B? What's the dimension of A by B? First focus over here. X is added with B. So these both must have same dimension. So dimension of X must be the same as dimension of B. Dimension of X is same as dimension of length. So dimension of B is same as length raised to 1. Okay. Now the potential energy So the dimension of V must be same as the dimension of A root X upon dimension of X plus B. That's what I'll get. Left hand side must be having same dimensions as right hand side. What is the dimension of potential energy? Same as work. M raised to 1, L raised to 2, T raised to minus 2. Force into displacement. ML T raised to minus 2 into length. ML square T raised to minus 2 will be the dimension of energy, work, all of them same thing. Here, this is the dimension of A. X is in meters. So this is L raised to half. And this bottom thing is again length only. So this is just L. So what will I get the dimension of A as? I'll get it as M raised to 1, L raised to 2, T raised to minus 2 into length. And this will go on the other side. It will become L raised to minus half. L raised to minus half. So what will you get this as? What will you get this as? M is raised to 1 only. L cube, L raised to 3, right? So minus half, which is 2.5, which is L raised to 5 by 2 and T raised to minus 2. That's all I get. So now divide A with B. Divide A with B. A by B dimensions will be. Dimension of A is this one. So it is M raised to 1, L raised to 5 by 2, L raised to 5 by 2, right? And T raised to minus 2, T raised to minus 2. Whole thing divided by B's dimension, which is L raised to 1. So it will become M raised to 1, L raised to 3 by 2, T raised to minus 2. L raised to 3 by 2 is there right over here, option B for biology. Very good. Congratulations if you guys got it. Congratulations. So lengthy problem but doable problem. You should see whenever things are added, their dimensions will be same. Okay. And numerator by denominator's dimension will be same as the left hand side dimension. That's what I have done over here. Great. Let's go to NEET 2015 question. Energy, velocity and time are related. The dimension of the surface tension. Now surface tension, let me tell you, formula S is nothing but force per unit length. That's what it is. So force dimension is M raised to 1, L raised to 1, T raised to minus 2. Whole thing divided by length. Whole thing divided by length will make the dimension of surface tension as M raised to 1, T raised to minus 2. That's the dimensional formula for surface tension. And this says that the surface tension is dependent on energy, velocity and time. Is dependent on energy, velocity and time. So what is the first thing? S is some constant into energy raised to x, velocity raised to y, time raised to z. That's all. So dimensionally, dimension of S will be dimension of energy raised to x, dimension of velocity raised to y, dimension of time raised to z. Dimensions of surface tension is m1 t raised to minus 2. m1 t raised to minus 2. Dimension of energy m1 L square t raised to minus 2. Dimension of velocity L1 t raised to minus 1 meters per second, right, raised to y. Dimensions of time t raised to 1 whole raised to z. Now this will become m1 L raised to 0 because no power of length, t raised to minus 2 will be, mass is there only once, so m raised to x, L is raised to 2x plus y and time is raised to minus 2x minus y plus z. So now once you get in this form, just compare the powers and you will get the answer. That's all. So you just have to write three equations. So power of mass is 1. So x is 1. Power of length is 0. So that is 2x plus y. And power of time is minus 2. So that is minus 2x minus y plus z. Solve this. You will get x, y and z. Out of that x value you already know as 1. You can find the value of y also from this and z also from this. Solving it, you must get this answer. X was 1, v is minus 2, t is minus 2. So I think both come out as -2, -2 only. Just check it out. If you get -2, -2, that's it. If you get -2, -2, so you know from this, it will be some constant into energy raised to 1, velocity raised to -2, and time raised to -2. That's how it is. Okay, straightforward, understood? Very nice. So this is how you derive relationships between a quantity and another quantity. This was a NEET 2015 question. Okay, next question. Force, velocity, time are fundamental. Then the dimension of mass will be just like the previous one. Mass is dependent on force, velocity and time. So mass will be some constant into force raised to x, velocity raised to y and time raised to z. So the dimensional formula of mass is same as force raised to x, velocity raised to y, time raised to z. Dimensional formula of mass is just m raised to 1. Force is m raised to 1, L raised to 1, T raised to -2. Velocity is length raised to 1, T raised to -1. Time is just T raised to 1, whole thing raised to z. So writing the missing terms, m raised to 1, L raised to 0, T raised to 0. They are missing, they are just not seen there. Here mass is there only once, length is there, oh this is x. So length raised to x plus y, and time is -2x minus y plus z. Just check that out. So compare the powers. Mass's power is 1 here. Oh sorry, why did I put 1 over here? This was supposed to be x. So 1 will be basically x. Then power of length is 0. So it will be x plus y. And the power of time is also 0. So it will be -2x minus y plus z. So solving this, you will get the value of x, y and z. Solving this, you will get the value of x, y and z. Just check it out if it is 1, -1 and 1. 1, -1 and 1. 1, -1 and 1. That's what you should get the value as. Yes, you can see that it is going to come out as that only. Very good. Very good. Very good. Proud of all of you if you have got till here. Proud of all of you if you have got till here. Now let's go to the last part. In NCERT it is not there, but I will just tell you about it. In NCERT it has been deleted, but for some reason. But the questions from errors do come in other chapters. So let me just brief you about it. Error is basically the uncertainty in the measurement. When I say there is an error, any kind of measurement, whatever kind of measurement you do, any kind of measurement that you do will have certain amount of uncertainty. What will it have? Uncertainty in that measurement, no matter what you do. No matter which instrument you use, whatever you do, there will be some anomaly, there will be some margin of error, and that is accepted. We take it for granted. So any measurement that you do will always have your most probable value, and also it will have the error in the reading. It will also have basically the error margin which is there. This is also called as the absolute error. Absolute error. Example, if somebody measures the length of some desk or some table or some pot or some anything, and they say the length is 5 centimeters, that is wrong, because you can never ever get 5 centimeters precisely. There will be some margin of error. So you will put this as plus or minus. Maybe the margin was 0.2 centimeters. Plus minus means it could be, so the length can be anywhere between, anywhere between 5.2 centimeters and 4.8 centimeters. So this is the range of length. This is the range of the length where it can be. I don't know the value. It might be 5.1, it might be 4.96, it might be 4.81, it might be 5.19, it might be 5.0005, anywhere in between. But I know it is somewhere in between this. Most likely it is 5, but there is a margin of error, and that is 0.2. Is that clear? Any measurement will have that uncertainty. So the uncertainty or the absolute error in this reading is 0.2. Now, any measured value or any measurement is often represented as m plus or minus delta m. Like I said before, this is most probable value. This one is your uncertainty, or just called as the absolute error. In that, you have a term called as something like relative error, and also the percentage error in the measurement. So what is relative error? Relative error is that error upon the most probable value. Relative, it's a fraction. And percentage error is that relative error you multiply by 100, you will get it in percentage. As simple as that. So say for example, I say the length is 10 plus or minus 0.1 centimeter. The relative error is 0.1 divided by 10, which is 1/100th. So if you measure 100, there is a margin of error of 1 unit. And the percentage error is 0.1 divided by 10 into 100, which comes out as 1%. So there is a error of 1% in the entire reading. Okay, so that's the meaning of relative error, percentage error, and absolute error, something which you should be aware of. Absolute error, relative error, and percentage error. Is this clear, my dear warriors? Okay, keep this in mind. So any measurement will have some uncertainty and a most probable value. There will be a quantity called relative error, which is error by most probable value. You multiply by 100, you get the percentage error in the reading. These are the three formulas. Now sometimes what happens, many students or many people conduct the same experiment and they get different values. Many students, they conduct the experiment and they get different values, and it happens in your lab also. One student is like, sir, the value came out to be 8, sir. One student is like, no, sir, the value came out to be 11, sir. Another student is like, no, sir, the value came out to be 10, sir. Another student is like, no, sir, the value came out to be 11, sir. Now, what will you take as the final answer? You know? So, what is the final answer? Because these are your readings. These are nothing but your readings. What is your final answer? Will you take it as 8? Will you take it as 10? So, what do you do in such cases? Let me show you step by step. First thing that you should do is find the average reading. What will you do? You'll just find the average value of these readings. So the average reading will be 8 plus 11 plus 10 plus 11 divided by 4. How much is the average value coming out to be? Today only it happened. Very good. Yes, we take average, but there are some catches. We will see that. What is the average? Come on, do the math. Is it coming out to be 10 only again? Like, sir, the average is 10. So this guy is correct. Okay, but these people were also giving some values. No, they got some different value. That means there is some room for error. 10 is most likely the value, but actual answer is not 10. Actual answer is not 10. So what you will do over here is you will find the errors in the reading, absolute errors. Absolute, this modulus, do you see? That modulus means absolute value of the error. So 8 minus 10, if I take the mod value of it, how much is it? It's just going to be 2. 11 minus 10, the mod value of it, how much it is going to be? 1. 10 minus 10, the mod value of it, how much it is going to be? 0. 11 minus 10, the mod value of it, how much it is going to be? 1. So it's the error. That means how much are you deviating from the most probable value by 2 units, 1 unit, 0 units, 1 unit. Okay, this much done? Everybody till now? Okay, the next step is find the average absolute error. Average absolute error. Average of the absolute error. Absolute means modulus. So it will be 2 plus 1 plus 0 plus 1 divided by 4. Come on, my dear students. How much is it coming out to be? How much is it coming out to be? Some of you have got the answer C so quickly. Very nice. Is it coming out to be 1? Very good. Now, the last step will be, you will say the final answer. The final answer will be, what will the answer be? It will be 10 plus or minus 1 units. 10 plus or minus 1 units. Somebody asks you relative error. Somebody asks you relative error. It will be 1 by 10. Somebody asks you percentage error. Somebody asks you percentage error. It will be 1 by 10 into 100. That means 10% error margin is there. So it's a huge error. Is this clear? Everybody with me? Very nice. So let's go to now the next concept, that is addition, subtraction, and then the last concept, which is, I think it should be there somewhere, multiplication, division in general. So what do you do when each reading has error and you are adding or subtracting those quantities with errors themselves? Meaning, imagine I tell you length of one object, or let's say there are 2 resistors in series. There are 2 resistors in series. This is 20 ohms plus or minus 1 ohm. This is 30 ohm plus or minus 2 ohms. What do you think is the total resistance? What do you think is the total resistance? What do you think is that total resistance of series going to be? What to do in such cases? What you should do is write those numbers, 20 plus minus 1, 30 plus minus 2. Just add everything, literally add everything. 20 plus 30 is 50. 1 plus 2 is just 3. So the answer will be, the final resistance will be 50 plus or minus 3 ohms. That's it. 50 plus or minus 3 ohms. So during addition or subtraction, just add as you do it normally. Okay, but what about, let's just take a duplicate of this. Yes. And maybe somebody gives you something like this. There is 40 kg of mass plus minus 3 kg. And somebody tells you there is also 10 kg of mass plus or minus 1 kg. You subtract these two. You are subtracting. Now what will you do? You subtract normally 40 minus 10, 30. There is no problem with that. But here, do not subtract, always add. This will still be 3 plus 1, which is plus minus 4 kg. That is your final answer. So the point is, when you are adding or subtracting, these values will add or subtract normally, but the errors are always going to add. Errors are always going to add. Errors will always add. Keep that in mind, not subtract. Will always add. Keep this in mind. So 3 plus 1 will be 4. Common mistake which many students end up doing. Is that clear? Very good. Very good. Now, if this much is clear, let's see whether we can understand multiplication and division. Actually, multiplication, division and some more things can be combined together. And in a general rule. Basically, the rule of powers. Any multiplication, division can be combined into the rule of powers. I'll give you an example. Look at this. Momentum is product of mass into velocity. Correct? Mass into velocity. Well, velocity is nothing but displacement by time. Kinetic energy is half mass into v square. Right? I can also say, just one second. Yeah. Time period of a pendulum is given by 2 pi root length by g. Here there is multiplication, here there is division, here there is multiplication, here there is division with root. Something weird is happening. All these kind of expressions can be written as a power form. Can be written down as a power form. What do I mean by power form? Start with a constant and take everything in the numerator and write it to the power something. That's what power form is. So observe over here. There is no constant, no problems. There is mass and velocity, both are in the numerator. So m raised to 1, v raised to 1. Isn't that? Velocity is s by t. There is no constant. Displacement is on the top. Bring time on the top. So t raised to minus 1. This is power form. So division, multiplication, everything can be written down in power form. So to solve the problems of multiplication and division, always use the power form. And I will tell you the final formula in a bit. Then kinetic energy. Half is a constant. Mass is raised to 1. V is raised to 2. Here 2 pi is a constant. Length is raised to half. G is raised to, on the top, negative half. Are you able to understand how to convert any formula into power form? Any formula into power form? Give me a thumbs up. Give me a thumbs up, my dear students. Everybody clear till this point? Very nice. Now the formula goes like this. So what is this power form? It says if any physical quantity is some constant into p1 raised to x, p2 raised to y, p3 raised to z, and so on and so forth, then the relative error in p, forget the constant, is modulus of x, relative error in p1, plus modulus of y, relative error in p2, modulus of z, that means always the positive values of the powers, p3 error, and so on and so forth. That's what it is. So this is the power formula. As simple as that. If this is true, then this is true. Relative error of p, forget the constant, modulus of the power, the quantity is relative error, modulus of the power, quantity is relative error, modulus of the power, quantity is relative error. Meaning over here, if I try to find the relative error in the momentum, it will be, there is no constant, so don't worry. Mass's power is 1, so 1 into delta m by m, plus V's power is 1, so 1 into delta V by V, which you can also write it as percentage error in the momentum is, if I multiply all LHS and RHS by 100, this by 100, this by 100, this by 100, 1 into anything is anything only. So percentage error in mass plus percentage error in velocity. Directly I got it. Percentage error in mass plus percentage error in velocity. Directly you can write it. Same thing over here. The percentage error or relative error in velocity will be power of s is 1. So 1 into delta s by s plus power of time is -1. Always take the modulus. So 1 into delta t by t. So that means the percentage error in velocity will be percentage error in s plus percentage error in time. That's all. Here I can say the relative error in kinetic energy. Relative error in kinetic energy is, forget the constant, power of mass is 1. So 1 into delta m by m plus power of velocity is 2. So 2 into delta v by v. Here relative error in time period. Relative error in time period will be 2 pi is a constant, forget it. Power of length is half. So half into delta L by L plus power of G is -half. Always take modulus. So half into delta G by G. Isn't that amazing? Such a simple way to solve any multiplication, division problems in the power form. Okay, if this is true, then this is true. Very important formula. Is that clear? Let's do some questions. Okay. Let's apply these questions. Time interval measured by the clock with the following readings are this. What is the percentage error, percentage relative error of the observations? This was asked in NEET 2020. Come on, do the math. What are the values? 1.25, 1.24, 1.27, 1.21, 1.28. First, find the average value. First, find the average value and see how much it is. Just see how much it is. Come on, my dear students. Come on, everyone. Add 1.25 plus 1.24 plus 1.27 plus 21. Yes, come on. 1.21 plus 1.28. Add all of them. Add all of them. Come on, see how much is it? See how much it is. And divided by 5 quantities. Divided by 5 quantities. Come on. Divided by 5 quantities. How much it is coming out to be? Everyone? Yeah, it is 6.25. Very good. So divided by 5, whatever those numbers are, divided by 5, see if you are getting 6.25 divided by 5 will be 1.25. Very nice. Now what you will do? Subtract this with 1.25 modulus. 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 This will be 0. This will be 0.01. This will be 0.02. This will be 0.04. This will be 0.03. Now you find the average of the absolute error. Average of the absolute error. Add all these numbers and divide it by 5. See how much are you getting. Come on, do that. Add all these numbers. 0 plus 0.01 plus 0.02 plus 0.04 plus 0.03. Add them and then divide it by 5. See how much are you getting. Somebody is already saying D for doctor. Add that and tell me how much are you getting. Come on, come on, come on. Very, very straightforward. .1, yes, divided by 5 will be 0.02. Very good. But that's not the answer. Answer is find the percentage relative error. So percentage error will be the error which is 0.02 divided by the most probable value, which is 1.25 into 100 into 100. Come on, do the math and tell me how much is this coming out to be. Shift the decimals, it will be 2 by 125 and into 100. You can divide this by 25 4 times, divide by 25 5 times. So it will be 8 by 5, which is 1.6%. 1.6%. Just check this out. D for oh, I think the answer given over here is wrong. It is D, 1.6%. Okay. Very good. Yes, awesomeness. No, Suresh, it is not A. It is 1.6%. Clear? Very good. Let's move on to the next one coming up on your screen. If the value of the acceleration due to gravity is given by this formula, g is 4 pi square L by t raised to 2. The value of the relative error of g is, already the formula is given, what more you want? This was in NEET 2022. G is 4 pi square L raised to 1, t is below, bring it on the top, t raised to minus 2. So what will be delta g by g equal to 4 pi, doesn't matter, 1 into delta L by L plus, always take the mod value, so 2 into delta t by t. Perfect. Is there an option like that? Is there an option like that? Option A. That's it, right? Perfectly correct. Very good, very good, very good. Excellent. Very nice. Let's go to the next question coming up on your screen, guys. Let's go to the next question coming up on your screen, guys. Here it is. The density of a cube of some mass and some edge is this much. What is the relative error in the density? Wow, nice question. First of all, density formula is mass by volume. Volume is length cube. Writing it in the power form, density is m raised to 1 L raised to minus 3. I just wrote it in the power form for satisfaction's sake. Now I will think that to find the error, I need to find delta rho. Error in density is asked. Mass has some error, length has some error, obviously density will have some error. I have to use the power form. So the power form says delta rho by rho will be 1 times delta m by m plus 3 times delta L by L. Isn't that right? Everybody with me? Great. Now, what is density going to be? Mass by length cube. Mass is 10. Mass is 10. Length is 0.1, but cube of it. So 10 divided by 10 raised to minus 1's cube, which will make it 10 raised to minus 3, which will make it 10 to the power 4 kg per meter cube. That's the most probable density. So that 10 to the power 4, I will put it here below delta rho, which I do not know, I have to find that out, is equal to delta m by m. Mass has an error of 0.1 and original value is 10 plus 3 times of delta L, length has an error of 0.01 upon 0.1 upon basically 0.1. That's what it is. If you want, you can just shift the decimal places so that it looks good. So it will be 0.1, or just write it like this, 0.01 plus this will be 0.1 only. So it will be 0.3, I believe. So this will be 0.31. This will be 0.31. So therefore, shifting this on the other side, delta rho will be 10 to the power 4 into 0.31, which is 31. I think we have missed some decimal places or what? (3100 kg per meter cube is what I'm getting. Point. Just check if some decimal places have been missed or something. Mass is 10. Okay. Length is 0.1. So I'm cubing it. So it is 10 to the power minus 3 becomes 10 to the power 3 into 10 becomes 10 to the power 4. Correct. No problem there. This is 0.1 divided by 10, which is 0.01, and this is 0.3. Yes. So 0.31. So it is coming out to be 3100. Just check that out. Just check that out. That's what I'm getting. So I'm guessing there might be, just check this out. This is, it's a cube, so 0.1 cube, 10 to the power minus 3. So I think there was some miscalculation in the options or something, maybe. Just check that out. Just check that out once. Oh, check density. Mass is 10. Mass is 10 and length is 0.1. Length is 0.1. No problem there. So it is what it is, 10 to the power 4. Just check it out once. Unless some decimal place was wrong somewhere. Just check it out once more. Okay. Anyways, I'll get back to you if there is some issue, right? I will ping you on the Telegram channel, right? Don't worry about it. So I think there was some issue over there, but we'll have a look at it later on. Anyways, the physical quantity depends on the 4 observables A, B, C, D as given below: 2%, 1.5%, 4% and 2.5%. The percentage error of Z is how much? The percentage error of Z is how much? Let's have a look at it. Okay. Now here, if you notice, Z is A raised to something, B raised to something, C raised to something, D raised to something. So Z can be written down as A raised to 2, what is it? B raised to 2 by 3 is there. Root C is below, C goes on the top, it will become C raised to minus half. D cube below, so D raised to minus 3 on the top. So the relative error in Z or percentage error in Z will be 2 times percentage error in A plus 2 by 3 times percentage error in B plus half times, always take modulus of the power, times percentage error in C plus 3 times percentage error in D. Is that right? Now substitute all the values. 2 into what is percentage error in A? A percentage error is 2 plus 2 by 3 times percentage error in B is 1.5, which is 3 by 2 plus half into percentage error in C is 4 plus 3 times percentage error in D is 2.5, which is basically 5 by 2. Okay, or you can just put it as 2.5 also, no problems. So what will this be? 4 plus 1 plus 2 plus 3 into 2.5, that is 7.5. How much is it coming out to be? 14.5 says already. Who is that? Rajban. Wow, very good. Check it out. 4 plus 1, 5, 5 plus 1, 5 plus 2, 7, 7 plus 7.5. Yes, it should be 14.5%. Let's have a look at it. Yes, it is 14.5%. Very nice. So this is one more question. I want everybody to post the answers in the comment section below. Okay, make sure that you solve it. Take a screenshot of this NEET 2023 question and post the answers in the comment section below. And make sure you're also a part of the Telegram channel so that you get today's PDF without any delay. And make sure you attend the quizzes which are going to be posted on Telegram. There are many activities that go on Telegram. We interact with students. We provide PDF. There are quizzes. There is motivation which occurs. There are group sessions that we often conduct. We also conduct weekly mock tests free of cost, and we send the link on the Telegram channel. That's the reason why you should be a part of the Telegram channel, my dear students. Okay, I hope your chapter number 1, units and dimensions, is absolutely clear in your head. We have discussed each and every concept from this chapter. There is nothing which is left untouched after this. Okay, so have a great time after this. And yes, Sarat, I will tell you in the thing, in the Telegram. So have a great time and God bless you all. See you again tomorrow for another lecture by another teacher, another subject, and I'll be meeting you also very soon. Bye bye. God bless you all. Take care. Hasta la vista.